Hello, everyone. Good evening. Okay, so let's start. I think we have enough audience. Hmm, Okay. So yesterday we covered time and space complexity. So basically, time complexity. Space part was not covered in detail, but yes, the time part we covered. Now, did you all solve the assignment questions of the time complexity that you had? Is that done? Doubts? Any doubts on the assignments? Some question? Okay. Firstly, tell me about the MCQs. All the MCQs is done. Addition and subtraction, both the questions will do. MCQs wala part, is that done? Anyone having doubts on MCQs? So we can discuss quickly and we can complete the MCQs. So I guess whatever I discussed yesterday, that's like MCQs are just that, right? Uh, Space complexities MCQs are remaining. So let me quickly start with first and space complexity, small part. We'll complete them, complete that, and then I'll explain. Acha. So see, space complexity is relatively simple, right? So similar to time, we denote the space as well in big O notation. Okay. So time we were denoting in big O notation. Space complexity also we denote in big O notation with tell it as big O of n, big O of 1, big O of n square, and so on. Okay. So how does how is the space related? So when we were writing time, it was making sense that is number of lines of code. Right. Now, how does space mean? Right. So we have different data types. We have different kind of storage. For example, we have arrays, we have normal variables, we have strings. Going forward, we'll learn about array list and so many different things. So how do we consider space? So when we calculate the space complexity, we don't consider any data structure. We don't consider any amount of any whatever the size of that data type. We don't consider those into example. Okay, we don't take that part into consideration. We simply find out the space. What is the space that's there? So for example, if I say intake or shoe1, I create a single variable, or if I create a single string variable, right? So both of them have a single constant space. We tell this as a constant space. Okay. Now, if you create even more variables of any particular data type, that is going to be a constant space. Okay. Similar to like how I told you about time, right? So in time, what is to happen is if you are writing a single line of code, that is constant time. Or if you are writing multiple lines, that is also constant. If you are writing a loop that is running for a fixed amount of iterations, that is also constant time, right? Same goes for space. Now if you create a space which is like going to which you can already know, right, where the compiler can know that what is the space that this is needing, all such kind of space is known as constant space. Okay, we call this as constant space, or we go of one space, constant space. Now what about different orders of one? So for example, if I create a array of n size, okay. Now what is this? If I create an array of 10 size, what is this space? So this again is a constant space, because this also is we have already told the size of it. Right? So you already know the size of it. So this is also a constant space, similar to running a loop for fixed amount of iterations. We used to tell that it is a constant time. Same thing. If you are writing an array with a constant size, that also is a constant space. Now, what is then like different other variations? So if you create an array of it, which is of n size. Now this is a order n space. Okay, so this is a order n space. Okay. Because you don't know the exact amount of space that you need, so this will be around order n. Now what is that upper limit? So similarly, if you create a like two-dimensional matrix, right, you would have done it in pre-course. We have not covered it, but this is how the two-dimensional matrix looks like, right? If you create it of n cross n, so this is order n square space. Okay, so this is the order n square space. Okay. Now, what is the upper limit of this space? What is the upper limit that we need to check? Is there any like order? If let's say we have order n space, we can create n of 10 to the power 8, 10 to the power 10, 10 to the power 12. Will it work? No. Same for the time constants. Like for time, we had a upper limit like 10 to the power 8 lines of code that is going to run within 1 second. Now, whatever compiler, whatever thing will use, that will validate whether our code is running within that 1 second or not, whether that is using that time frame 10 to the power 8 lines of code and running within that 1 second or not. Here, same thing, the space would also utilize. So generally the compilers are configured for 10 to the power 6. Okay. So all the online compiler that I mentioned yesterday is configured around roughly 10 to the power 6. So you can create an array of 10 to the power 6 size if you are creating a single dimension array. If n value is at max 10 to the power 6, you can create an array like this. If n value is like if you are creating a 2-dimensional array like this, and which is having a space complexity of n square, so your n value can at max be 10 to the power 3, because this is going to give you 10 to the power 6 space complexity. Okay. So in like in most of the cases it is 10 to the power 6. In some compilers it's like even 10 to the power 5, and somewhere it even allows a little bit higher number. So for example, this compiler I guess allows you up till 10 to the power 7 or 8. Let's validate. 4, 5, 6. Try to run this. A is already defined. First, let me comment this. Where else is defined? Okay, we don't see any errors. Now, if I try to do it as 10 to the power 7 and try to run it, we still don't see any error. 10 to the power 8 and run it. Okay, still it works fine. So let's take 10 to the power 9. See, Java heap space. Now, what is the error it is showing? That there is out of memory error on Java heap space. It was trying to create this array of 10 to the power 9 size into the heap section of the memory that we understood about stack, heap, and then there is a string constant put. So all the arrays goes into the heap section of the memory, right? Irrespective of whether you are providing the size in the compile time or in the runtime, that that array will always be created in the heap section. Now you'll get an error something like out of memory from Java heap space, right? This was unable to create an array like this. So here it has allowed till 10 to the power 8, but in the normal compilers, you would see something like this, a restriction of 10 to the power 6, beyond which you won't be able to create use space. Okay, so let me write it over here. This is space complexity measure of amount of space used. So you are allowed to use 10 to the power 6, create an array of 10 to the power 6 or any linear structure. Like for example, array is one example of linear structure. You'll see other examples of linear structure like linked list, stack, queue, right? So all these examples of linear structure, you can create 10 to the power 6, even non-linear as well. There also the highest top limit is 10 to the power 6. Okay. After which the compiler starts giving you error. In few cases, 10 to the power 7 works, but 10 to the power 8 and 9, they are definitely going to give you errors. If some compilers even at 10 to the power 6 range gives you errors. So you generally see if you are ever required to create an array of something like this, your compilers would have given you constants like 10 to the power 5, right? So to be on the like safest side, so that doesn't give you any error. Yes, yes. So time and space is always a high priority question. Every time you solve a question in interview, the first question that interviewer is going to ask you after you explain the solution and you like you did well in that code, the first question that you're going to get from your interviewer is what is the time and space complexity of this particular code. Okay, so that is the very first question that you have to like you'll get after writing your logic. Okay, so time and space complexity are always important. But it is up to online compiler side. But when I use IDs in our system, SSD hard disk space. No, when you use compilers in your system, there then it is like dependent on your RAM size, right? So it would vary depending on your RAM. Since the code is not running on hard disk or SSD, right? It is consuming space from your RAM. So let's see. Let's try to figure out how much space did we have over here. Okay, so this was running 10 to the power 8 was running fine. At 10 to the power 9 we failed. Okay, so let's check how much amount of space is this. So this is 10 to the power 8 into 4 bytes. Yes, because each integer is 4 bytes. Okay, so it is, or we can say 4 into 10 to the power 5 kilobytes. I just removed 10 to the power 3 and assumed it kilobyte. Or I can say 4 into 10 to the power 2 megabytes or 400 MB. So we almost used around 400 MB of space when we were creating array of 10 to the power 8 size. Now, when we are creating of 10 to the power 9 size, we are using 4000 MB, which is approximately 4 GB of space. Now, this one, the compiler is not allowed. Okay, so let me explain this calculation again. See, so we were in this particular example, in this particular compiler. Okay, we are considering this compiler which was allowing 10 to the power 8 and it broke at 10 to the power 9, right? So it was allowing till 10 to the power 8 and at 10 to the power 9 it started giving error. Now if you go beyond it, the same error will come, right? So at the 10 to the power 8, if you have an array of 10 to the power 8 size, what is the actual memory that it is consuming? So it is 10 to the power 8 and each array is integer, so it is going to be 4 bytes. So you can write 4 bytes into 10 to the power 8, or if you just remove 10 to the power 3, you can convert it into kilobytes, right? Or you can like this is writing like this, right? 4000 into 10 to the power 5 bytes. Yes. So I just took 3 zeros out of here, and this is 10 to the power 5 into 4000. So what is 4000 bytes? Roughly around 4 KB, right? It is not exactly 4 KB, right? But you can, for rough calculation, you can use this, right? So roughly around 4 KB. Okay. Now, if you again convert this into, this is 4000 KB into 10 to the power 2, right? So this is 4000 KB is nothing but 4 MB. Okay. So it is 4 MB into 10 to the power 2, which is 400 MB. So it allowed us till 400 MB. And even if we take like 2 into 400 MB, 3 into 400 MB, for till that point also it might allow us. So for example, this is breaking, right? Which is 10 to the power 9. So if I run this, so it is telling me out of space, right? So let me remove 1 0 and let me just add a, instead of 2, 1, let's change it to 2. This is 3, 7. Okay, so till 2 also it is fine, which is 800 MB approximately. Till 3, which is 1.2 GB. Okay, so this is also fine, and it's not throwing errors at least. Now 10 to the power like 4, which is 1.6 GB. So this is where it is breaking. So most likely it has given us around space around 1.5 GB of space that we can use. Like if we exceed our space uses more than 1.5 GB, it starts throwing us error. Okay, so like it is not very strict over here. Same goes for other compilers as well. 2 into 3 into like sometimes 4 into might also work. But for example, when you have 10 to the power 6 constants, so is it strictly 10 to the power 6? No. 2 into 10 to the power 6, 3 into 10 to the power 6, 4 into 10 to the power 6. The like small variations might work, but there would be a certain point where it will break. And 10 to the power 7 is never going to work. Okay. No. Even if it's running in RAM, it doesn't work that way. So anything that's running has to get its space from RAM. Okay, so let me explain you in little bit in detail. Okay, see, so we have different segments, right? We understood this. We have cache, we have RAM, we have like we can have SSD, we can have hard disk, right? We can have external hard disk, or we can have floppy disks, all those things. Whatever code is running, okay, so cache is very small, so ignore the cache for now. Cache has like nothing to do with, we don't have anything to do with cache. It is very small amount of it, 2 MB, right? It cannot help us in any way, right? So it is so cache is out of question. So now we have RAM and we have SSD. So anything that is running, right? Anything that is running, so when I run the code, right, so any running application will consume space from RAM. We can have storage in SSD or we can have storage in hard disk, but the running application will always get its space from RAM. So for example, if let's say tomorrow Chrome starts taking 4 GB of RAM. Okay, just to run Chrome, I need 4 GB of RAM. When as soon as I start the application, Chrome needs 4 GB of RAM to run. So any system having like less than 4 GB or equals to 4 GB, they won't be able to run Chrome, right? Because they have other processes to run in parallel as well. Even an 8 GB system might sometimes hang very frequently. Chrome starts to take 4 GB RAM. Because there might be other applications. For example, I'm running Zoom, I'm running a like pen, I'm attached to an audio system, I'm attached to a sound system, right? So all those devices also need some RAM to be running. Now, those all devices cannot run if they don't get that space from RAM. Okay, so any running application will get space from RAM. So I'll talk about a little bit about operating system concept. Very interesting concept. So okay, so this is a very interesting thing. So how many of you have ever played games on PC? Anything, right? Any small game like NFS or IGI or like Assassin's Creed, any game which is like little bit heavy, right? GTA Vice City, yes, that used to be heavy. GTA Vice City was little bit like on the lesser side, but yeah, some games which are very high end graphics, they are generally of very high the Far Cry, yes, Far Cry can be a good example. So they are very heavy, right? So for example, let's consider your mobile application where you have like PUBG, and PUBG is around 1 to 2 GB. Okay, let's for simplicity consider 2 GB. PUBG takes PUBG size is 2 GB of time. Okay, the PC games that run on PC are actually more than 2 GB. It's like sometimes they are 21 GB, 30 GB, 50 GB, right? 9 GB, right? So such kind of applications. There are applications which are even heavier than this. There are applications which are 50 GB. Adobe has a lot of applications which are used in photo editing, video editing, and they are around 50 GB, 100 GB size. Okay. Now, will a 8 GB system be ever able to run this? So actually, earlier it did not used to run this until a very unique concept was introduced of how we can run this heavy applications into our using our 8 GB or limited amount of RAM. Okay, what interesting है. So what they did was, you see, let's say I'm running Chrome. Okay, and let's assume for simplicity, okay, there are applications, but let's assume Chrome is 14 GB. Okay, and my RAM of system is 8 GB. So I will never be able to run Chrome, right? If I start running Chrome, I don't have that much amount of memory, so my system will immediately crash. Okay, so we'll keep on loading. Once the memory gets filled up, right? So when you see a situation like your system gets hanged and all those things will happen because your memory is full. So what we do is, see, so we have the entire Chrome application is 14 GB, but what the operating system does is like it is the responsibility of the operating system. You'll understand this concept in depth when you'll learn about operating system, and this is asked in interviews. Okay, so you cannot skip this topic. This is there in interviews. Interviewers ask what is page, how does pagination work, or what is segmentation. These questions are direct questions that you get in interview. Okay, so what operating system does is, so let's say the Chrome is 14 GB. So operating system will break Chrome into smaller pages. Okay. Now, how small the pages will be? Let's say 100 MB pages. Okay. So it will break this application of 14 GB into 100 MB pages. We call this as page. Okay. 100 MB size, and how many pages, how many such pages we'll get? So we'll get around 10 and 140 pages, right? Around 140 pages. If it is 114 GB, right? So let's say Chrome is 14 GB and we are breaking it to 100 MB pages, and we'll break it into 140 pages. Now, let's say whatever feature of Chrome I'm using, right? Whatever, so all these features, so Chrome has, let's say, a lot of features, right? We have, let's say we are running a site, we are running a video player. Chrome has an integrated video player with it, right? Whenever you play a video automatically plays. You don't need to download any external software, right? Chrome has an audio player attached to it. Chrome has a support for visual images. Chrome has support to like even debugging your code, right? So there is an inspector that you can open, right? So for example, this is an inspector that you can open and you can debug your code, right? So there are hundreds of such features that there in Chrome, and which makes Chrome very heavy. Okay. Now, what operating system will do is it will divide it into 100 such small pages, which are like mostly feature wise, right? So whichever feature I'm using, this is the code of that particular feature. Now, let's say I'm just opening Chrome to search for something on Google, or just opening to view some tabs. I'm not playing a video. I'm not viewing images. I'm not, let's say, like using the debugger to debug something. I'm not using extensions that's there in Chrome. So a lot of features I'm not using right now. So all such things does not need to be loaded into my RAM. So it will decide, the operating system will decide which all pages are important from me. And let's say it picked out, let's say out of these 140, 12, 15 pages are important for me. So it will give me that these are the 15 pages which it will load in the RAM, and out of 8 GB that we had, we gave 1.5 GB, which Chrome is currently using to run this 15 pages. Now, let's say like I want to use some additional feature which I'm not using right now. Let's say I'm just open the debugger. So operating system will load that page into the RAM and it will open the debugger then. for me. This is very fast, which operating system, this page switching, all these things, operating system does very quickly. So you won't be able to see any lag or any significant difference in how your normal software would work, or this like pagination concept is causing. It's yes, it's similar to thinking like functions. In the code level, it's similar to like thinking functions. Whichever code we want, that code we are that our functions we are calling. The functions that we don't want, we have just parked them, that's there in memory, but we are not calling them. Okay, so same thing happens over here, and this entire process is known as pagination. And this is actually how any software runs in modern world. Any software that you use, any application that you use, it uses the concept of pagination to be run into your system. So now you can download a 20 GB software, even if your system has only 4 GB or 8 GB of RAM, you might be able to open it and run it. Okay, earlier, if like this system was not there, you won't be able to open it. Once you click open, your system would hang, and it would be frozen until you shut it down and like restart the system, until those things that were loading into them gets completely erased. Okay, because once you try to open it, all the things would start getting loaded into RAM, and your RAM would become flooded, right? And it would break. Now, sometimes like when you start to use more features, right? You would have observed this, when you start to use more features on the application, when you do continuous interactions, you open more Chrome tabs, you are playing a video, you're listening to a music, you are watching, let's say you are playing a game, you're doing so many things, your system still hangs, right? Because you're trying to, even though we have paginated it, now you're trying to load too many pages into the RAM. And even if it is paginated and you're using a lot of functionalities, a lot of pages will get loaded and RAM would still die out. Okay. So that can still happen, but like operating system has tried to give you a way to run this heavy application given with the limited amount of RAM you have. Okay. Now, let's come back to our discussion. So why is this related? How is this related? So whenever you run any application, there is no way application can run on SSD or hard disk. There is no way. No application runs on this part of the memory. All the applications run only on the RAM of the memory. Okay. So whenever you, so a program, right? Whenever you write a code, this is just a running software. You can treat it like a running software. And here we have not told about what is needed, what is not needed. We have made divisions on the features, or we have tried to load a particular feature and we are not loading a particular piece of code. Everything runs at once. Okay. Everything, whatever you have written, everything runs at once. Whatever arrays you are creating, whatever variables you are creating, everything gets created into the RAM. Okay, so if you create an array like this, it will immediately create require that much amount of space from the RAM. And now let's say the RAM has given this code around 1.5 GB to run. Okay, it is not giving it more than this. Okay, so whatever this online GDB has configured, so they have configured it. At max, you can use 1.5 GB while running a code, and you cannot use more than that. Now, when I'm using an array size of like 4 into 10 to the power 8, so this is exceeding this. This is roughly equal to 1.6 GB, which is exceeding this. So we are seeing error. But when we are running 3 into 10 to the power 8, which is roughly around 1.2 GB, so it is like still at the like very verge of exceeding, but it is not exceeding. So we don't see any errors in that part. Okay. So this space is always consumed from the RAM. This is even though you have like, so that's why attaching a very heavy hard disk cannot improve your system until you sort the RAM problem out. So RAM is the place where your applications run, no matter how many external things you add to your system, like SSD or hard disk or a graphics or something. If your RAM is very limited, your system is going to be like restricted to just within that RAM, right? If you cannot use heavy things until you expand that RAM of your system. Okay, same goes for code, right? If I want to run a heavy code, I will need more RAM space. I need a better compiler. I need, so compiler would be same. I need more space from the RAM. I need a better processing, so that since we are using more space, the code would also like start taking more time to run, right? And same 10 to the power 8 lines of code that follows, right? Understood? Clear? So this is all about space. Now, so I gave you the constant that you have to follow, 10 to the power 6. Generally, in most of the constants, you'll see it as 10 to the power 5. Okay, rarely you will get a constant like 10 to the power 6 and you have to create an array. If the question requires you to create an array, 100% will say 99% at least, so you will have the constant as 10 to the power 5. Okay, there might be some rare case where you might need to create it 10 to the power 6, and that works, right? That works in most of the compilers, so that's why it is there. But generally, it is one lesser so that you don't run into this heap out of space errors kind of this thing. Okay, because you can't do anything about this error, right? There is nothing for time complexity. We can optimize, right? We can write a better solution. But if what if I am asked to take an array of 10 to the power 6 size as input, so I don't have any workaround, right? And if I want to store it into an array, I don't have any other workaround. Instead of like we need to create that 10 to the power 6 array, right? If we are storing it, yes.
So I have a small doubt, sir.
This is big.
So the 10 to the power 6 is fixed for all type of data, like integer, long.
Yes, so it is like a general constant which is given to us 10 to the power 6. Now, yeah, your concern is correct. Like key integer will take 4 bytes, but long will take 8 bytes, right? So for long, it should have been lesser, right? So that's why like the compilers would give you a constant like 10 to the power 5. Okay, so that's why they don't give you 10 to the power 6 exactly, because if you are taking long, it might breeze that size. Okay, so
Yeah.
okay, we have that number for strings. For example, if you take very long strings inside a string, for in strings, if we create a string array, each string can each string can be of 100,000 characters or 100 characters. Now there the there it is like even consuming more space, right? So if you create a string array of 10 to the power 6 size, okay, and your each string stores 100 characters on average, let's say. So this is 10 to the power 8. This is like so here it is 4 into something. It is 100 byte each string is taking 100 bytes. Here each of them were taking 4 bytes and we still exceeded, right? Here it is taking each string is taking 100 bytes, so we are definitely going to exceed, right? So those things would be like would happen, but we are given this restriction. Somewhere this clause will it will exceed and it will breach. In most of the cases, like I'll say, like from whatever coding I have done, right? So I have rarely encountered this space error. Time error is always going to there is a time limit out of exceed. That is a very common error that you see, because that you can optimize. Space wise, the questions are set in such a way that you would never face space issues if you have like solved it in the optimal way, or even if non-optimal way also. Space issues are very rare. Okay, string takes 100 bytes. No, all the strings won't take 100 bytes, right? If you have put 100 characters into it, if you have put only 3 characters into a string, okay, if you have just put 3 characters into each string, right, so it is going to be 3 bytes, right, which is less than the array that you are taking of integer, right? Each integer is 4 bytes. Here you are giving 3 bytes, or if you take 2 characters, you are getting 2 bytes, right? So string would vary depending on the number of characters you have stored in them, right? But here array is like integer. All these data types are fixed, right? So they won't vary. Okay, now let's take this example here in order of n. So if n is 10 to the power 6, you are fine. Here if n is 10 to the power 3, you are fine. If n is greater than 10 to the power 3, then this would give you space error, right? In module 1 final interview, you might get a small question on time and space, not this much very detailed, right? They would just simply ask you what's the time and space complexity. This is for your understanding of how this thing actually works in memory. Okay, why this heaps exceeds, right? Or how this is running, right? How RAM works or how the hard disk works. Okay, carries 2 bytes. Yes, sorry, carries 2 bytes, right? So it is 3 characters going to be 6 bytes. Yes, sorry for that. Yeah. Okay, so I'll solve questions. I'll solve. Okay, done. So this is about space, right? This is all about space. Now you whatever size of array you create related to n, it can be log n array, it can be a square root of n array. So all the complexities that you have over here, right? All the complexity n factorial 2 to the power n and n to the power 4 square root log n square n. So all of them are also there in space as well. Just that in space you are creating a data structure. Most likely for now it is array. Later going forward, you might create a stack or queue or a tree or a map or something like that. So they would also consume the same amount of order n or n square spaces. Okay. Chalo, one simple question I'll ask you. Tell me what's the space of this one. And I is equals to 1, I is less than equals to, let's say. So I have written an array of 10 to the power 8. Okay. And I'm creating an integer a I'm taking input from you. Acha, chalo, let's give you one simple thing. I'm just giving value 10. Okay. So I'm running a loop for 10 to the power 8 times, and I'm creating a variable named a, which is having a value 10. So what is the space complexity of this logic? Constant. We have 10 to the power 8 variables. Okay. Now, why this is constant? So actually, we are creating 10 to the power 8 variables. That statement is true. Okay. So we are actually creating 10 to the power 8 variables, but all these variables never exist simultaneously in the memory. Okay. What does this mean? So for example, when this first iteration of loop runs, I create a variable with name a and I store the value 10. Okay. And then when the loop ends, we free up this space. So the memory that you have allocated to any variable, be it array, be it uh, like a normal variable, be a string, once it goes out of scope, right? What is out of scope? Once the curly bracket that where this variable is accessible, that ends. Okay, once this curly bracket ends, we call it as out of scope of this variable. Okay, once this variable goes out of scope, that memory gets freed up. Okay, so the like Java has, every language has this free memory, every language this gets freed up. This the part of the compiler that actually frees up this memory, that is known as garbage collector. Okay. So this is like, if you ever hear the term garbage collector, what it is. So this is the part of a compiler. Every language have their own implementation of garbage collector, how they define when they should free up their space. In Java, the definition is very simple. Once a variable goes out of scope, that is garbage collected. Okay, it is complicated in few languages. For example, JavaScript has a very another world of garbage collection. Okay, when you learn about JavaScript in the advanced modules, where there you can ask this question: how does JavaScript's garbage collection works? And that is very different. There, out of scope things get like it doesn't work in how it works for Java. Again, Java, it is simple. If anything goes out of scope, just put it in garbage collector, will simply free up that space for you. Okay, simple. So whatever the time complexity of it is equal to the space complexity, no. So here, like, we can write a loop of order n, right? So this is the time complexity of this loop will be order n, but the space complexity is constant, right? So space complexity is depending on how much space you create, right? So now this logic is giving us a constant space. Why? Because we are creating 10 to the power 8 variables, but every time we create a new variable, the previous variable space is cleared out. We do it for 10 to the power 8 iterations in the loop. So we create 10 to the power 8 variables, maybe in like on very different places of memory, but every time the previous variable is freed up. So we are not at any point of time using more than a single space. Okay. Understood? We cannot now, if when garbage collection is running in background, right? Yes, whenever the code runs, right? Whenever code runs, it is actually so whenever you are running a code, right? Whenever the compiler is running, whenever the runtime is running a code, right? So it automatically, so it gives you memory, right? So when this memory allocation, so this compiler gives you memory, right? It knows that it is going out of scope, so it will use the garbage collector to collect that memory and then give you another memory. Okay. So it is giving you memory, it is taking a previous memory. So that is how this garbage collection is working. Okay. So always have that freed up space. How time complexity? So this is constant time complexity, but if I write this loop for order n, right? So if this loop is order n, so this is like big of n time complexity, and the space complexity is big of 1. Okay.
Hello, sir. One thing I want to ask, sir, if I initialize the array size of 10 to the power 6 and data type is integer, then the size content is 4 into 10 to the power 6. And if the array size is long, then the space like 8 into 10 to the power 6.
Yes, yes.
Then, sir, if the
Okay, so I'll say, you see, this 10 to the power 6 constant that I'm telling you, right? This is not a hard constant. We don't know what the size, what is the amount of exact amount of space that lead code is allowing us, or HackerRank is allowing us, or AMCAT will allow you, right? So we just take a general convention that up to 10 to the power 6 is allowed in all the compilers. Beyond that, it is like it might be problems. At 10 to the power 7, 10 to the power 8 will give you problems. 10 to the power up till 10 to the power 6 of whichever data type you create, that is not going to be problem. Okay, so make this assumption, and like so it is actually generally
Sir,
higher.
is 10 to the power 6 is bytes, sir?
10 to the power 6 is so this is like the size, the number of integers variables. The part of the number is the size of the array that you are creating. Okay, and this is bytes. So each integer is 4 bytes, and we create. So for example, we are creating an array of like 10 to the power 6 size. So, and we are basically, what is this array? Nothing but blocks, right? Each of these block is 4 bytes, which is storing a single integer, and we have such 10 to the power 6 blocks. Okay.
Okay, sir, got it.
Yes. So in this case, how the space is big of 1? See, because we don't have any other array or anything, right? We just have one variable inside this. And this is what I'm trying to explain, that if you have a single variable, even though you are creating it 10 times, right? But the next variable only gets created when the previous one is freed up. So you will never have n simultaneous variables using your space, right? Here, all the n variables simultaneously can never use your space. Once like one iteration of the loop ends, the one variable goes out of space, and that memory is freed up. Similarly, second iteration of loop ends, that variable space goes out of scope, and that memory gets freed up. And same goes for the third one. Okay, so it keeps on happening for n times. So that's why, since this loop is running for n times, our time is always order n. And since we are never using n variables simultaneously, and we just have only constant space, so it is big of 1. Time will be order n. Yes. So time and space can be different. Time is here order n, space is order 1. Okay. So time and space are not related. Time is varying on how many times, how many lines of code you have. Space is varying on how you have what is the amount of space you are using. Now, what is garbage collector? What can be a definition of this? So let me write it in a very simple way.
So sir, space is mainly the variable space, sir. What we are initialized.
Yes. Garbage collector. So this is like, you can tell it as an observer, which frees the space of variables going out of scope. Okay. So any variables that goes out of scope, the garbage collector looks for it. It frees up that space so that other variables, other arrays, whatever you want to create, they can reuse that space. If the arrays have n long, then it will be if it has if it has n long, then also it doesn't matter what. That's what I'm trying to tell, right? Even though the data types are different, right? Even though you create a long array of n size, then also it is order n. Okay. So we have not. So BIGO doesn't bother about the data type or anything. So BIGO is just to give you an idea about it. Okay. So BIGO simply tells you the idea. That what is yes.
So actually, I didn't mean the data type. Actually, I mean the length.
Sorry.
The n long means I mean the length of arrays n.
Okay, length is always 10 to the power 6. That is around roughly fixed. So this is like, see, 10 to the power 6 are same to time, right? Time and 10 to the power 8 बहुत hard नहीं था. Time in the time constant, 10 to the power 8 was like our topper limit, beyond which it will start taking more. But 2 into 3 into 4 into 10 to the power 8, those were working, right? Even I told you in some cases 7 or 8 into 10 to the power 8 also might work. Right, but 10 into 10 to the power 8 won't work because it is going to 10 to the power 9, right? So that won't work. Same logic over here. This 10 to the power 6 is not very strict. So 2 into 3 into that works even if you take an integer or a long array, or even if you take a double or a float array, those works. Okay, that still works because this is not very strict. This compiler, for example, is giving us and no issues till 10 to the power 8 size, right? 10 to the power 8, 3 into 10 to the power 8 also it is working fine. From 4 into 10 to the power 8, it starts giving problems, and from there on, whatever number you increase, it gives us a problem. So roughly around 1.5 GB. Same is like over here. It is like lesser side, like 500 or something MB would be there, which we are allowed to use. 500, 600 MB, 700 MB. Beyond which it will topple. right? So for integer longs, this is not big problem. Strings is a special case, because in strings you can create a single string of very large size, right? Acha. Now here the concept that I initially told you about rebalancing, that is very important. So for example, let's say I told you that there are three parts of your memory, right? One is the stack, one is the heap, and then there is a string constant pool of the heap. And I told you that this rebalance themselves depending on what is the space. So for example, your stack is not using too much space, your heap is not using too much space, and your string is using too much space. So this will expand, the string constant pool would expand and the heap would shrink. Okay, so they will rebalance among themselves to run the program, not that the space for heap is fixed or stack is fixed and string is not going to get more than this. Even if it's exceeding, will throw the error. That does not happen. Okay, now in case of string, it is a little bit tricky, because in case of string, you can write a string a is equals to new string array you can create, which is of 10 to the power 6. Okay, now till here it is fine. But if you create each string value inside this, right? Each string inside this is a very long string, let's say 50 characters or 100 characters, right? Then that is 100 bytes. Now that might break, right? That might not work. So for string problems, you'll generally see the size of strings are given in this range. Even if it's array of strings, they would be given in this range, and the largest number of characters in each strings would also be given as 1000 characters. Okay. Now this balances out, right? 1000 characters, and if the string array is of length 10 to the power 3, so your total size is 10 to the power 6, roughly in the order of this. Okay. So that's how like strings are taken care of. So generally in string questions, you'll see constants like this, where you can take each string of 1000 size or 100 size, and the array, if it is a string array, then at max the string length would be 10 per 3. Okay. But in case of arrays, it doesn't get released, right? In case of loop, so here the space is getting released every iteration, but here you're right away asking that give me this much amount of space to start writing my code, right? So in case of array, it's not getting freed up. In case of normal variable, it was getting freed up, right? So there is a difference. In when you have an array, so you're telling that give me the space, you will be using this space until this array goes out of scope. When it is going to happen? When your code actually ends, right? So until your code is running, you're using this much amount of space. Now, if you have asked for 10 to the power 9, 10 to the power 10 space to create that array, your Java is actually going to tell you that I can't create this much space. So I can't give you this much space. So this is a heap error, right? Your space is going out of the heap area. I rebalanced everything. I gave all the stack space to the heap. I gave all the string constant space pool as well space to the heap, but still it is going out of scope. So I can't create this array. So for example, which the error that we are getting over here. Okay, understood? Okay. I know this looks like a very big mess, but like if you try to think of a solution, how you will figure out a workaround, this would be the solution that you will approach to, right? You'll give space. Now you need something to free that space continuously as well, because you want to reuse that space, right? You want to rebalance between the spaces. So if stack is not getting used, you can give that space to the heap to run the code. So the entire goal of the compiler is to run your code anyway by balancing the space, by freeing up the space that is not used, right? And it will try to do its best until it there is no way, it doesn't have that space which you are asking, right? So it will say you the error right away that we can't create this, we can't. Now this can happen in runtime as well. So is this always a compile time issue? No, you can create a like a variable n, and you can just n is equals to sc dot next int. Okay, so this error can happen in runtime as well. So if you are trying to create a very long array, okay, let's say 4. Input mismatch. Did I give too many zeros? So we have 0, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. 8. Could have given 8. That should be fine. So let's say 5, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So in the runtime as well, this error can happen. So it's not just so that time compiler was knowing during the compile time, so it was not even allowing us to run the code. Now this error is happening during runtime if we try to create an array of this size, right? So Java immediately knows that I don't have this much amount of space that we are asking to create. Okay, what this understanding of space, where it is problem, what's the limit, how you can tackle it, what's the complexity. So complexity wise, it is simple, right? Whatever you saw yesterday, that's the same thing. Order n square, order n cube, right? We'll see multi-dimensional arrays. You'll understand about 3D array, 4D array that there I'll explain. So n cube, n to the power 4 spaces will make sense over there. Okay. Otherwise, most of the time it's order n. 2 and 3 and you can also treat that as order n. Okay. So for example, 2 and 3 and space, you can treat it as order n. So for example, in time also we were writing if the number of lines of code is 2n, so we used to write it time complexity is big of n. Same, the number of amount of space you're using is 2n. So that also you can say big of order n. Okay. Can we calculate space complexity if you are only given time? No, they are completely independent. Space and time are not related, right? So there is no way to know the space complexity given the time, right? So you can do the same question using constant amount of time. So our ideal goal should be to use the least amount of space, right? So like right now you might use extra spaces. That's not a big problem. Okay. Sometimes we will also see logic where we can use additional space to reduce the time. Okay. So there are logics, for example, merge sort is an example. So when we'll understand about sorting, there I'll explain you how using additional space can reduce the time complexity. So there is a trade-off as well in a lot of questions where you can use some additional space, but that will give you a better complexity, right? Counting frequency of digits, or there are a lot of questions where you can use hash map. So hash map will give you additional space complexity, but time-wise, it can reduce your time drastically. From n square, you can, or n cube, you can jump to order it directly. Okay. What is m minus n loop? So if you are running a loop for m minus n times, right? If you are running a loop for simply m minus n times, so if you have two variables, let's say m and n, and you are running a loop that is running for m minus n times. Okay, so that is big of m minus n. See, this expression is just that how many lines of code you have. So if it is a variable, so for example, I have I loop which is running for I less than equals to m minus n. Okay. So what's the time complexity here? We don't know, right? There are two variables and we don't know what's the difference of this is going to be, right? Even so, the best way to tell it is big of m minus n. Is there any example where time complexity is less than the space? Generally, you would rarely see like you're using more space and less time. It's never the scenario, because if you are using a order in space, right? If you are using a order in space, in order to initialize this array, you will require a order n loop, right? So your time will always be equal to like order n, or like you will write if a nested loop that will be n square, but you can't go less than this. If you are creating a data structure which you're not initializing, in that case you will you might find a order in space and a constant time. But what's the use of creating a order in like data structure and you're not even assigning values, right? So generally the time will be equal to space, or time might be greater than space. Hash map and stuff is asked in 6LP. Hash map is the easiest thing that you will see, right? Hash map is one of the most easiest topic that you will see, right? And that solves your 99% of problems that you're getting. Okay, so let me first complete this theoretical discussion. I'll take like another 30 minutes and then I'll go to the questions. I'll start with a very interesting question. Yesterday I wrote it over here. Hash map is very easy. Hash map is one of the easiest things. Concept wise, it's like if once you understand the concept, right? If you will sound it's like so fun concept, right? The concept is super fun. It is very easy to write. It's very easy to understand. Once you get used to writing hash maps, it's very easy. So let's say, I wrote this part, I did not explain this part. So let me explain you this part as well, right? So this is also done, so I don't leave anything here. Okay, so the memory part, last thing, which is address versus reference, okay, or physical versus logical address. So you get this question, what is address and what is reference? How does a reference, so why do we call our array variable as reference? Why don't we call it as an address? How does a reference differ from an address? Okay, or what is the difference between a logical or a physical address? So these are like very common interview questions that you get. So let me explain you then this way. Okay. Okay, think of our memory as, so this is our memory. Okay, very I told you, right? It is like a grid, which is like having boxes, very, very small boxes. Each box responsibility is to store a single 0 and 1, right? That's what I told you. So there are boxes, and each box's responsibility is to just store a single 0 and 1, and that's it. Okay. So you have so many boxes, and each box is just storing a 0 and 1. Now there is an address that is given to each of these boxes. Okay. And I told you it's like similar to, you can think of your house address, right? It has a what's the lane number, what is the street number, what's the house number. Similarly, it has a some address using which we can figure out what's the value that is stored in this particular address, whether it is 0 or 1. Okay. Now, this address that we have of memory, right? This address is known as the physical address. This address that is the actual address of memory, this we call as physical address. Okay. The address that is of actual memory, जो घर का actual address है, right? The actual address of the home, the actual address of that memory is known as the physical address. Okay. Now, sorry. Okay. So this address of the memory, which is actually there, which is known as the physical address. Now, what is logical address? So we never see the logical address ourselves. Okay. So so the physical address ourselves. We never get to know what's the physical address of that memory is. Who knows this physical address? The operating system knows this physical address. Okay. The only thing that knows this physical address is the operating system. We never know this physical address. Okay. So for example, like right now I'm using a Windows device. So only Windows knows what is the physical address of the hard disk or physical address of the RAM, wherever this calculation is happening. Whatever address is given, what's the physical address of that? Only the operating system knows. We don't know that. Okay. So what do we know? We know the logical address of it. Now, what is logical address? So I'll give you a simple, it's very easy to understand example. So let's assume that this is the physical address of the this bit of information. It looks something like this. Might have some hexadecimal characters as well, or let's say 28. These are not there. Generally, physical address is very complicated, APC, something like that, right? Very like a long address of this bit. You can assume, right? There are so many bits. If you have a 1 TB hard disk, there would be so many bits, right? Now, even if you order them from 00001, it will be so many. It will be so many combinations of it. Now, this address has to be given in such a way that I cannot give it in order wise, right? I cannot give it like 00001, 00002, and so on, and then I start with 00. I can so it is given in such a way that from the address I can know which row this memory is, which column this memory is, right? Where or if it is like even more complicated than this, whatever the memory looks like in the electronic device, whatever is the electronic gadget, be it hard disk or something, it will take care of, right? So वो उससे पता चल जाएगा from this physical address. Now, if I ask what is the physical address of this, compiler is not going to tell me. If this operating system is not going to tell me, it is going to tell me a logical address. Now, what it is going to tell me, it is going to tell me some address like this. Okay, let's say it tells me this is the address. Now, what's the use of this address? This is not even the physical address. If I ever tell this logical address to the operating system that I want to change something in here, I want to do some operation over here, it will actually figure out the physical address and it can actually change the value in that physical address. Okay. Now, and there is a lot of usage of this. This is a very simple example. Now, why is there two address system, right? We could have just operating system could have just told me the actual address, but it doesn't work that way. For example, let's say when you create an integer variable, right? Integer a equals to 4. Very simple. Okay. How many bytes of space it is using? It is using 4 bytes, right? 4 bytes is 32 bits of space. Okay. 4 into 8. So you are actually not using a single physical address. You are using 32 bits of space, which will be continuous, right? So you want 32 bits of space to get edited if you want to write a. So when you are telling a is equals to 10, what you are doing? You are updating the value. Don't worry how it is actually happening, but in actual memory, what is happening? Those 32 bits are actually getting new values, right? With some 0 is changing to 1, some 1 is changing to 0, something is happening in 32 physical addresses, right? Now, if I give you 32 physical address and I tell you that this is the address, this, who? Okay, sorry. So we have 32 physical addresses that we have to edit whenever we are changing a value of a. Right now, we don't want to know this, how this is happening. Neither we are worried, right, whether 32 addresses are getting edited or all those things. We don't even want to deal with that complication. So we'll write this entire logical address. We'll simply tell that this is the logical address which corresponds to this 32 physical address. So that also, for that purpose also, logical address can be used. So logical address can point to multiple physical addresses as well. And when you say that I want to update this logical address with this value, it will actually update all those physical addresses which is actually getting edited. Okay, understood? So logical addresses, similarly, there are a lot of applications of logical address which is used. So we always see the logical address. We never see the physical address of the memory. We always see the logical address of the memory. Understood this concept? So if you ever get a question, what is physical address, what is logical address? The simple explanation is physical address is the actual address in memory. Okay, so let me write it over here. So physical address, this is the actual address in memory. And logical address, this is the address. This is the address which we see, that corresponds to a physical address. Address or slash addresses. Okay, so it can even correspond to multiple physical addresses. Okay. So is it creating logical address at that time itself for 32 bits through predefined notation? Yes. So whenever we create, so who is doing this transaction between our code to the operating system? So this transaction is actually handled by the compiler. What our compiler says? Our compiler says to the operating system, give me 4 bytes of memory. Okay. So compiler will not tell ki give me 32 bits of memory. I will edit the 30. Compiler can't do that. No compiler can do that. So compiler, see, there is three parts, right? We have our code. Our code is run by the compiler. And then there is operating system which deals with the memory. Okay, so there are like 4 entities over here. So we've written some code and let's say we are writing a equals to 5. Okay, just let's understand this small example, you'll get the idea. So I'll say, so when we are running this, so compiler will ask the operating system, I want to create a variable of 4 size in the RAM. Give me 4 bytes in the RAM. So operating system will go, it will, so it knows 4 bytes is 32 bits. So it will reserve 32 bits of actual memory from here. And since we have asked it all together at once, this 32 bits, operating system will give us in return a single logical address which corresponds to this 32 bits. Okay, so it will give us a single logical address, let's say something like this, which corresponds to this 32 bits of memory. Compiler will store that, okay, this is the address which is storing this variable. Now, wherever if I write a equals to 10, it will simply tell the operating system, this was the address where I stored a previous value, use this address and update its value to 10. Okay, so operating system knows, okay, this address is having actually 32 bits and I have to store this new value 10 into those 32 bits. It will store it. Okay, so MAC address is an example of physical address. So the MAC address is an actual example of physical address. So it is the address of the physical device, right? So that is a physical address. Your IP address is an example of a logical address, right? If you know about networking, so there also this same concept is there. In networking, you have a concept of IP address and you have a concept of MAC address. So for example, let's say right now I'm connected to internet and I'm talking to you all. So I have a IP address using which I can be tracked. So this IP address will change next time I log in, next time if I disconnect and reconnect, it might change. If I turn off my router and I start again, it might change. If I connect to a different, let's say Wi-Fi, it will change. So IP address, this will vary. Okay, but the MAC address of my system is fixed. This is fixed. I cannot change the MAC address of my system. This is a physical signature of my system that I'm leaving over internet when I'm connected to you. So if tomorrow someone has to track me back, who did this, so that is the MAC address is definitely going to track me back. Okay, and this is very difficult, right, to track back through MAC address. All those like security things are there, but yeah. So these are the 2 addresses that I use while communicating to the internet. Microprocessor use physical addresses, like in microprocessors there is like all these complexities are not there, right? So they directly give you physical address. They have a very small amount of memory, right? Some KB or something. Okay. port is basically the different, what I would say is different. So there are, let's say, assume there are a lot of okay, so for example, let's say you can connect with your system to, you can run a multiple applications in your system, right? All those applications want to use some networking, some internet, right? So for example, Chrome is also using internet and my Zoom is also using internet. So they both will, the operating system will get that you use this code to use the internet, you use this code to use the internet. So whenever you will tell me using this particular code that this is the internet call, this is the network call that you want to make. So I will know that Chrome is making. Whenever you send me from this code, that is, I will know that Zoom is making. Okay, so that is known as the port number. We use it for development purpose. That you'll understand in very detail. Okay, don't worry. That is like, I just gave you a simple explanation. Okay, so now this discussion can continue, right? This is nice. I know this is a very interesting topic. We can talk on this, how hacker track the IP address, how these things work. So let's come back. Firstly, let's me complete this. Understood what is logical, what is physical address? Is this clear? This is a direct question. That's why I'm explaining it in very detail. See, these kinds of questions will differentiate you from all the other engineers or all the other people who are interviewing, right? They will not know these things in this depth. Okay, no one studies this, right? You are never taught in this college. We should teach this theory. At least this is theory, right? This should be taught in this crisp way, but it is not taught. Okay, so no one cares about this logic. Everyone knows programming. Okay, so nowadays, like the more knowledge you have on these things gives you additional edge, because I have seen actual engineers know a lot about this. They are very, very like into this and they know a lot of things. Is this theory in a book? I think I'll try to find out those books, but you can find a lot of articles online. Okay, which will explain you this in very detail. I'll give you one thing. You can download an app known as Hashnode. Hashnode, you know, I guess. Hashnode. So I use this to read very frequently. Yes. You can do that. There are a lot of blogs around programming and this concept. Every day, if you start practicing reading 1, 2 blogs, 3 blogs, these all concepts will become very, very strong. Okay, the DSA book, that is someone please share the link in chat. You already have that link, right? I know. That's Narasimha Karamanchi. You can search that. Okay, I'll show you at the end. Okay. Understood this? Understood the physical and notice I have not explained the difference between address and reference. This I have not explained. Okay. Now, what is address and what is reference? Okay. So whenever I say about address, so this is the logical address. Okay. So whenever I say about address in code, I simply mean the logical address. We don't know the physical address. So there is no way I will ever say that we are this points to physical address. It always points to logical address. Okay. What is the reference? Reference is simply a variable pointing to a logical address. Now, what is an example to this? So this is very simple to understand. Just take this. So for example, let's say I take int a is equals to new int and give it any size. Okay, doesn't matter. Just print system.out.println a and you run this. So for this, you will see. So this is the logical address. This address that you're seeing over here is a logical address. Okay. Now let me copy paste. No. I can't copy these things. Copy. Yes. Yeah. So this is the logical address. If you print this, you get something like this. You might see something very different in your compiler output. Okay, so that is fine. This will be the logical address. And what is the reference over here? So reference is a variable that's pointing to this logical address. Which variable is pointing to this logical address? The array variable A, right? So that is a logical address. So that is a reference. So A is the reference. This is a reference. Okay, understood? So logical addresses are simply referred as addresses in programming in terms of code, and reference is nothing but a variable that points to this. In C++, you have pointers. So those pointers are nothing but references, right? So in C++, you refer it as pointers and they point to some address. So that address is the logical address. Can we print the reference through logical address? No, the reverse is, I guess, not there. So reverse we cannot do. Compiler, there might be some method that the compiler is, at least I'm not aware of that in Java. Never felt that necessity, right? So you'll never need to do the reverse, like from logical address to variable, but you always need to like do this. This might be like useful. Okay. There might be some methods definitely on in the compiler level, but at the Uber level, I don't know any such method which I can pass logical address and get the variable. Okay, understood. Okay, clear. Address wala concept. Now is address clear? Now is the memory concept strong? Now do you understand memory, how it works in code? What memory is in code, how it gets allocated, how it gets freed up, what are the address, how we refer to them, what a variable actually is, what an array variable is actually, right? What is this reference, what is this address, how this pointing works, all those things. Yes, sorry, someone is saying something.
Hello, sir. Sir, one thing I want to ask, sir, if I initialize that int a equal to 5, then I get logical address.
Int a equals to 5. This.
Yes. Then we get
For this, actually, there is no way in Java. Okay. In C++, actually, there is a way known as pointers. So in C++, basically, there is a way, for example, you can create something like star p is equals to ampersand a. Okay, you can do something like this. This is a C++ code. This is not a Java code. Okay,
yes,
so in
sir.
C++, you declare variables and you use pointer to get the address of it. But in Java, there is no such way that Java is given. Okay.
So in Java, we always use reference.
We always use this reference. So we call this arrays as a reference. Okay. So these are actually just variables, right? We don't call them variables. They point to some. So reference is a variable which you print, you will get the actual address, right? So when we print this variable, we are getting this address, right? So for example, in C++, the example that I just gave. So here A is not the reference. Here this P is the reference which is storing the address, right? So the definition of reference says that it should store a logical address. A is not storing a logical address in our code, right? So it is just a variable. You cannot mix with. A is a variable, and in this A array is a reference because when we print it, we actually see the address. Okay.
Okay, sir.
Got it?
I got it.
Okay. So in C++, there is way to figure that. Yes.
Then how to know the logical address of that int a?
In Java, there is no way. In Java, does not give us any way to know that. Like it's not as per Java, it's not required. So Java did not build that functionality. And
so only we get the logical address of the arrays.
Yes. And this also we will never need, right? Because in code we are just using them, right? In C++,
so in Java side, we cannot modify anything with the address.
We cannot modify anything with that. We can use variables to modify them, right? We can modify
that only use variable name.
Yes, we use variable names, but in like for example C++, which is more close to the
actual, yes. Because sir, in C I see that I change the value with the address.
We can change the value with the address, right? So for example, this same statement. So like let's say this gives us the address, right? For those who don't know C++, this is just a statement which will give you the address of this variable. Address of A. So now if you write something into this, so if you like for example, you cannot change this address, but if you do something like star p is equals to 15, what it will do is it will change the variable in value in A, but we are not changing via the variable. We are telling that whatever is the address over here, update that value, that address value to 15. Now coincidentally, A is also pointing to that same address. So when you print A after this, you'll see that A's values had updated to 15. We changed the value. So like we actually did this. So did not tell that update A. We told that whatever address, let's say A is pointing to AB123. Okay. So we told that update the address AB123 to the value 15. Okay. Coincidentally, A is also pointing. So after this operation, if I print A will print 15. So Java cannot use address. No. So in Java, there is no concept of pointers, so we don't. Got it, sir. Got it. Okay. So in case of so now like there was a earlier concept that I explained you. So is this even required? No, not required, right? Just C++ gives you some additional things, right? It is very older language, I'll say. So it has given even minute thing to, if you want to manipulate that address thing, you can do that. In Java, it doesn't feel that it is necessary. Well, anyone ever requires to do it at code level. So Java says that, okay, let's not keep that functionality altogether. Now I talked to you about our concept of call by value and call by reference. There I explained that what is call by value, right? So now call by reference would like it would start making a little bit of sense to you. So call by value kya tha? So let me just open the functions wala part where I talked about this and complete this discussion as well. Okay. So I might not start with 2D arrays, but I am fine with it because I have already talked about 2 additional classes this weekend, Saturday, Sundays. So okay, yeah, will not miss out on anything. Okay, so see, so here I talked about like call by value, right? So what was happening is whenever we are calling a function and passing some value, the writing some variable as well, only the value of that variable was passing, right? So for example, here in this function sum, only the value of the variable was passing. Why this was happening? Because in case of normal variables, we don't have any address, we don't know those addresses, so we can't pass that addresses to any functions or anything. So whenever you do this, actually the like only the values are passed and there is copies of these variables that are created over here. But if I do the same thing for a for a thing like, let's say, array, okay, so let's create a public static void update, okay, and let's pass a array into it. Now in this array, if I just try to do this as a small operation, a of 0 is equals to 100, okay, and don't even do a return or anything. I've just changed this arrays from a of 0 to 100, okay. So let me just create a array, new int 10. Let me just print this system.out.println. I print a of 0. Okay, I call the update function where I pass this a, and then I print this a of 0 again. If I run this, see, the actual arrays a of 0 is getting updated. Why? When you are passing a, so what is happening here is, now in case of a, since in case of normal variable, it was passing value. Okay. So in case of normal variable, it didn't know the address, or there was no way to figure that address out. So we only can pass the value. Okay. So there is no way it is going to work. But in case of array, we know the logical address. So what is happening over here when you're doing this, it is actually passing the logical address and it gets the same logical address over here. Now, when we are updating it, we are actually updating the original array itself. Okay. So if no matter wherever you access it, the original array is getting updated. So there was no copy of it that was created. So for example, when you created call by value, okay, for normal variable, always call by value works. For example, int, float, double, boolean, string is also call by value. Okay, so keep this in mind. String is call by value in Java. Okay, now that I'll explain why string is call by value. Even though it looks like a reference thing, it is not a data type as other variables. It is a reference type. Why it works, I'll explain you that in very detail when you learn about strings. Okay, I'll tell you how strings actually work. Okay, that's that's there in this module itself, so you don't have to wait too long as well. Okay, now coming to this question, why is this happening? So in case of array, it is call by reference. So what happens is, whenever you're creating an array, we create a space. Okay, now this space, let's say it is initially 0, right? So the default value is initially 0. Now, when you call a function and pass this, it is actually passing the logical address. It is not creating any copy. So this function had a variable a, which is pointing to this. Now this function has a variable a, which is also pointing to this. Okay. So this function doesn't know anything about this a. This function knows only knows it's a, that I have a variable a, which is storing this array. Now if I update a of 0, it will update this particular index. So there was no copy actually that was created for array. So that's why this is known as call by reference. We pass the actual reference and any update on the function will reflect in the actual array. Yes, that is one correct way of saying exception with the exception of string. Okay, so you can think it of like this as well. So anything that is there in stack is called by value. Anything that's there in heap is called by reference. Just strings are not called by reference. Okay, so there is a different logic for strings. Okay, so for that reason, strings are not called by reference. Apart from that, anything that's there in heap is always called by reference. So for example, arrays, objects, right? Going forward, so every other thing is like object type, right? So every other thing that you will be creating is object type. So there are only two types in general, arrays and objects. Okay, so array is a special kind of object and which is like inbuilt. Apart from that, everything else is simply object type. Okay, so strings strings are like except string pool. Yes, so you can treat it like everything is called by value except a heap part, which does not include the string pool. Okay, okay. So let me repeat this part. So let me show you both call by value, call by reference. For those who forgot a little bit about call by value. See, so here I wrote one example. Let me just clear this out once. And this was the sum function. Okay. So see what I was doing over here. I'm just written two variables, int a equals to 10, b equals to 20. I'm passing these two variables into I'm printing them and then I'm calling a function by passing these two variables. Now here I have created same two variables a and b. I'm first printing them and then updating it. I'm printing the values after their update, and then this function call ends. I come back to the main function. I print the values over here. Now if I run this code, there was one thing that you would see something different than the behavior that you would expect is if we see before call it is 1020, which is fine. Okay, this is fine. Now before update, now we call this function, we went inside this function. Before update, we are printing 10 and 20, which is fine because we passed 1020. So this should be 1020. Now we updated these two values to 100, 200, and we see the value after update 100, 200, which is also fine. Till here, everything was working as expected. Now, when this function call ends, we come back to here and you print after call, you're not seeing 100, 200, you're seeing the previous value of A and B, which is 1020. Now, why is this happening? Because when you pass normal variables, anything that's stored in the stack part or like the string, including string, right? That gets passed by something known as call by value. In the function call, only the values of the variable is passed. There is no knowledge of where this variable is, where this value is stored. So that function creates its own copy, right? So and we already know, right? In a block, the variable only exists within a block. So now these two are two different blocks. So this is the main block and this is the function block. So main block had a variable 10 and b variable 20. This function had a variable 100, b variable 200. So a variable was 10 and 20, and then we changed their value from 10, 20 to 100, 200. Now, when this block ended, these two variables actually died out, right? They died out. And when we came back to the main block, these two variables were not affected by that update. So we are still seeing 10 and 20. Now, this thing does not work in this way for arrays because in case of arrays, these values are not this. There is no copy of this data structure that is created. Okay, there is no copy of this data structure that's created, and there is like just the same copy that is passed. So in case of array, you will actually see the original array getting updated. If you pass an array to a function, let's say update this function that we just created, and this function is just updating any array index value. So this will actually update the original array. So here we had an array, we printed the value with before this update, which was 0 default value. We called the update function, passed the array. This function is updating the array, had nothing to do about with this. And then when we came back, we are actually seeing that updated value. So call by value is copy. Call by reference is which passes the logical address altogether. Okay, this was my Microsoft interview question. Okay, what is the difference between call by value, call by reference? And this was there in the first round itself, right? And I guess this was like the second, third question itself. Okay, so this is very important concept. Yes,
sir. One thing I want to ask, sir. So, sir, in Java, we cannot do swap to variable without call by value.
With call by value, actually, you cannot. You need to return that value. Now that becomes tricky. There is the swap function is trickier to implement over here. right?
Because in C, this is a very easy program, sir.
C is very, you can pass the reference to that, right? But in you can use ampersand to pass the reference and you can receive that. But here it is not possible.
So what we can do in here, sir, for this
So
one?
you just create that variables over here, right? You just create int like temp over here, right? Temp equals to A equals to B equals to C, B equals to temp, right? This logic.
Other than that, we cannot swap.
No, because in function that will be called by value and it won't retain that, and there is no way to pass a variable by reference.
So if we, in one code, if I need swap 10 times, then 10 times we write this.
Yes, actually you will need to. I don't think there is a way. There is actually a way of by using objects. So basically you can get a workaround by creating an object which is like call by reference. So which is basically you're creating additional space, but not by the normal variable. There is no workaround by using normal variables. Okay.
So we can know it in objects.
We can objects is it can be done because objects is reference. So basically, like you would see, generally it is swap functions are there, but they actually take these values, they create a reference to it. So they will create object, and then object is called by reference. So they don't. There is no way actually to get this working for variables.
Okay, sir. Okay, sir.
Okay. Why array don't lose the value, still be able to update it? Because array is call by reference. Okay. So what is call by reference? See, so I wrote the definition of call by value. Now look at this. So in what is call by reference? So arrays are passed by reference. Okay. So in function call, the actual address, the actual reference is passed. Okay, not address. We don't. Actual reference is passed. Okay. So here what happens is, since the other function knows the address, it doesn't create any copy of it. It updates the same address. So we see back the result, right? So array में कोई copy नहीं बनता, ठीक है? ऐसे सोचो कि array में वेरिएबल में कॉपी बन रहा था, उस फंक्शन के पास अपना कॉपी था वेरिएबल से, उसके पास अपनी वैल्यूज थी, एरे के पास है ही नहीं, एरे कॉपी बना ही नहीं रहा, एरे सेम लाइक यहाँ पे मैं एक्स भी लिख दूं इसको तो भी ये सेम एरे को पॉइंट करेगा, इसकी वेरिएबल से भी कोई मतलब नहीं है, यहाँ पे कोई भी वेरिएबल हो. सो इवन इफ दिस इज अ डिफरेंट वेरिएबल नेम, इवन इफ यू गिव हियर अ डिफरेंट वेरिएबल नेम, इट वुड स्टिल वर्क द सेम वे. व्हाई? Because we are passing reference, even though we store it in some other variable, do anything, there is no copy of it is getting created. Okay, simple. No copy is getting created, so the same array will update. Okay.
So, sir, call by reference is mainly like pointer.
It is like pointer. It is just pointer. So in like Java, it is just pointer. So it's like in C++, you can do it for everything. Here you can't do it for everything, right? You just can do it for arrays and objects. Okay. How many total rounds of Microsoft? I had 7 rounds. I had very rigorous 7 rounds. Yes. Call by reference is not clear. Still, Praveen did not get it. हिंदी में बता दे एक बार. चलो एक बार हिंदी में बताते हैं, ठीक है? लेट मी जस्ट कवर वंस इन हिंदी. ओके, देखो हमारे पास 2 तरीके हैं. जब हम फंक्शन कॉल करते हैं ना, तो एक होता है कि भाई हमने वैल्यू पास कर दिया, ठीक है? वैल्यू पास कर दिया तो वैल्यू पास, जैसे हमने वेरिएबल कॉल करा तो वैल्यू पास कर दिया, यहाँ पे कोई टेंशन ही नहीं. फंक्शन चाहे कुछ भी करे वैल्यू के साथ, वो उस फंक्शन में लिमिटेड रहेगा. जब हम वापस आएंगे यहाँ पे, तो हमारी यहाँ पे जो वैल्यू थी वही रहेगी, ठीक है? ए बी जो हमने इस फंक्शन को पास करा है वो चेंज नहीं होगा, किसी भी कंडीशन में ये चेंज नहीं कर सकता, ठीक है? तो यहाँ पे जब हम वापस आएंगे तो 1020 ही दिखेगा, वो वैल्यू चेंज नहीं दिखेगी यहाँ. और ये नॉर्मल वेरिएबल्स के लिए वो कहता है, इंटीजर, फ्लोट, डबल, बुलियन, स्ट्रिंग्स, ये सारे वैल्यूज ले लो, ठीक है? नाउ जो एरे हो गया ये थोड़ा स्पेशल है, एरे, और फिर आगे जाके ऑब्जेक्ट्स भी पढ़ोगे आप, तो ऑब्जेक्ट्स भी थोड़ा सा स्पेशल है. वहां पे क्या होता है कि हमें एड्रेस पता है, ठीक है? ये अगर प्रिंट करो तो लॉजिकल एड्रेस दिख जाता है कि क्या एड्रेस है, किस एड्रेस को पॉइंट कर रहा है, हमें लॉजिकल एड्रेस दिख रहा है. जो भी हमने समझा ना, फिजिकल एड्रेस, लॉजिकल एड्रेस होता है, तो वो एड्रेस हमें पता है. तो ये क्या करता है, एड्रेस पास करता है, ठीक है? ये बोलता है मैं कॉपी नहीं बनाऊंगा, एरे तो बहुत बड़ा भी हो सकता है, लाइक उसमें 10⁻⁶ नंबर्स हो सकते हैं, मैं क्या बैठ के सारी कॉपी बनाऊंगा? ये कंपाइलर बोलता है मैं नहीं करूंगा इतना काम, मैं एड्रेस ही पास कर देता हूँ, वो अपडेट करे फंक्शन, मैं सेम एरे को अपडेट कर दूंगा, ठीक है? सो अब जब मैंने एरे पास करा, यहाँ पे मैंने पहले प्रिंट करा A0 में वैल्यू क्या थी, तो उसने प्रिंट करा 0 थी. फिर मैंने ए को पास कर दिया अपडेट में. अपडेट क्या कर रहा है कि भाई उसको अपडेट करना है, x0 को कुछ भी नाम रख ले, वहां पे कोई भी वेरिएबल नहीं हो जाए. सो वो अपडेट कर रहा है उसको 100 वैल्यू के साथ. अब जब इसने 100 वैल्यू के साथ अपडेट करा, तो क्योंकि कोई कॉपी बनी ही नहीं थी मेमोरी में, एक ही एरे है मेमोरी में, सो वो सेम एरे अपडेट हो गया। अब जब हम यहाँ पे वापस आके इस फंक्शन में प्रिंट कर रहे हैं, जो पहले हमें इस फंक्शन में चेंज नहीं दिख रहा था, अब हमें दिखेगा क्योंकि सेम एरे चेंज हुआ है और यहाँ पे हमें 100 दिखेगा। ओके, JS use same approach by almost same, right? Almost say and say this is almost same in call like in a lot of languages. So like const let that is called by value, objects are called by reference there, and there are a lot of different types of objects. Arrays are called by reference, and there is a lot of variations of that. And there is like garbage collection is completely different there. So a lot of concepts are different in dynamically typed language in Java, like JavaScript. Yes, how many rounds of DSA? So I would say key 1, 2, 3. No, 1, 2, 3, 4. 4 rounds DSA. Around 3 to 4 rounds DSA. Yes. 4 rounds DSA. Yes, 4 rounds DSA. One was like director level, and one was, so they were combined, right? So actually, I had my intern and then job. So intern had 4 rounds, and job had 3 rounds. So total 7. Okay. So that's how total 7 rounds took me there. Yes, you can use JavaScript for DSA, but JavaScript is even more complicated than this. So understood this. So this is all about this concept, and so I can give you a dinner break. So before I give you a dinner break, I'll tell you a very interesting thing. So do you know about relative hiring? What is relative hiring? No? Any idea? Okay. So see, there are 2 ways you get hired. Okay. One is based on your knowledge. Okay. So for example, let's say you know things. Okay. So, and there is a open position for which the company is interviewing. Okay. So the company would interview you. You will generally get like around 10, 12 questions. Some may be like theoretical. What is difference between call by value, call by reference? What is logical address? What is physical address? What is pagination in operating system? Solve a DSA question. You might get a DSA question as well, right? What is fall through? Right, all this, what is the advantage of having fall through? Can we use it in some place in our coding, right? So what is explicit casting? All these things. What is time and space complexity? So you might get a lot of questions, and you will also see DSA problems. You'll see questions from networking, operating system. So that is basically judging your skills. Okay, and whether to check you are basically qualifying the criteria to you are basically meeting that bar of whatever company has, right? This we want at least candidate, we should know these things, fundamentally should be strong in these cloud. So that is like normal hiring, it works. Then there is relative hiring, which is little bit difficult than this. So what happens there is, so you generally don't see it at fresher level. Fresher level, it's rare, but at experience level, when you go to 1 year, 2 year, 3 years experience, what happens is there like for a vacancy there are applications, and there are like everyone has worked on industry, so everyone knows a lot of things, right? So working in industry gives you even altogether different knowledge than learning these concepts, right? So there you will use them, and then you will have more advantage of it. So if the interviewer asks basic questions like this, every candidate is going to answer, right? Now how is he going to decide, right? So sometimes what the interviewers do, they just like schedule call one by one. So they'll schedule a call with the first candidate. If he answers all the question, if he is fine, so they will say, okay, let's recruit this. Let's not even schedule a call for others, which we have shortlisted. Okay, so they will not even approach those candidates, and that's done. So that's why you'll see most of the time, like while applying for 2 years, 3 years experience roles, like 70-80% of the chance you won't even get any response. You will not, even though your profile was good, you were shortlisted, but it's just that someone else's interview was earlier than you, and you also performed equally good. It's not that you are not, you will not eligible for that job, or you could not have done. Just that someone else chance was luck was better. Okay. The other kind of approach, which is painful for the recruitment team or a lengthy process, but it is also followed, and there these things will help you. So what the interviewers do, they will bring let's say 3 to 4 or 5 questions at max. Okay, 3-4 questions. Like first one will be easy to medium, then it will have a little bit harder question. Then the difficulty will increase to extremely hard questions. Okay, extremely hard questions, so you would see difficulty to this. So interviewers is expecting, let's say it's asking 3 questions. So you'll expect the candidate who doesn't solve even one, so he is right away rejected. Okay, the candidates who solves one, So he's like, okay, it's okay. In the second question, he struggled, he did not solve. So he'd assume that, okay, this would be the last result I would go to. If there is a candidate who solves two, so you'll see, okay, this is good. He solved two questions. And the third one would be extremely difficult, right? That you would never expect anyone to solve. Okay. So he would have set it up or picked that question from somewhere such that like so depth, it would require so much complicated logics to solve that question actually. No, it is necessarily does not need to be a DSA question. Okay. Most of the times I'd say that is not a DSA question. Okay. That is more of related to concept like these, like very fundamental concept, so that he understand. Everyone knows DSA, he knows at that level. He wants to understand who knows whose fundamentals are the most strong among all the candidates I have to interview. And he'll pick one of those candidates. If anyone answers that extremely hard question, which the interviewer is not expecting anyone, so he will hire that candidate immediately. If he doesn't find any candidate answering the third question, which he expected, so he'll pick out of those candidates who answered two questions, and out of them whose profiles is best, whose previous experience is more helpful to like with the project that he would align it to, right? So he would see evaluate using those parameters. So in those places, showing these fundamental, very strong concepts, sometimes like the interviewers are really impressed if you solve those questions, which in interviewer never expects anyone to solve. Okay. How many of you have watched pictures? So this concept was told there, but not in this way. Have you watched TVF Pictures? There was a new season of it that recently came out. So there was like in the coding interview, there was like some questions that G2 has set up, and whichever candidates. So there was a new season where like there is a engineer, he has set up a particular set of questions, like there were 5 bugs in the question, and whichever candidate came, and he asked the candidates to figure out those 5 bugs. Okay. So it's like which candidate knows how much fundamentals. So he never expected any candidate to figure out those 5 bugs. The like candidate who figured out the most bugs was 4, and he hired him. Right. Other candidates were not able to figure out 2, 3, or 1 bugs. Right. Then there was a candidate who figured out 6 bugs into that question. And that was like the super awesome candidate that they told this is the super awesome candidate. He figured out 6 bugs. So that is an example of relative hiring that happens. Okay. And that is mostly for senior levels. You'll 2 years, 3 years down the line, you're going to face such kind of hirings, right? So my experience is 2 years, 3 months now. Right. So most of the interviews, if I appear, right, I am not appearing, but if I appear, so I'll say that most of the interviews would be kind of relative hirings that I would face now. Okay. So at this point, you need to know this very depth, because the questions are extremely difficult, and I am basically trying to prepare you for that, so that you don't need to learn things 2 years down the line on this fundamentals. Your at least fundamentals are very strong, and that time you can learn any language, right? If these fundamentals are strong, you can easily learn JavaScript or any language, which is like more advanced than Java and uses more complicated concepts. Okay, clear? So this is what memory is, this is what time is, this is what space is. Any doubts from this assignments? Any doubts that's left from this time and space complexity? What's done? A gym is fine, right? Gym is fine. You should practice just from gym. Okay, just from gym. Whatever theoretical concepts I'm telling you, okay, don't forget them. Just right, I'm sharing that, so I'm writing it over here. And if required, watch these recordings later also. Try to make small notes of this after the classes if you require. But generally for me, notes never helped, because that used to get lost. So I used to now keep things in my mind. I don't have any notes tracking this. Now when students ask notes for this, I don't have any notes, to be honest, because I myself have to look where is this things noted down. On the internet, you can easily find blogs that mention these things about how garbage collection works. If you just Google how garbage collection works in Java, you'll get a detailed article. You need to just know the basics. This is like what the basic is. There might be depth things on this as well. Okay. What is physical, logical address, all those things, you'll get the idea. You can like whichever edition you use. I even use a very older edition of Narasimha Karamunchi. That's also fine. The newer edition will just have a few more additional problems or something. That's Dungeon Master. Yes, that was the person who figured out 6 bugs. So that is an example of relative hiring, right? Here it did not mention, but that is one unique case. When I'll explain sorting, I'll give you very real interview example. This was like from a series, but I'll give you a real interview example of how sorting can be a very big thing in interviews. Okay. Chalo, I don't think you have doubts over here. So, okay, try to complete them. If you still have doubts on time and space complexities MCQs, we'll discuss them. Okay. Now let's come back to arrays. Okay. I have few things to discuss on arrays. Before going to this part, I have something to discuss. Okay, I have something very interesting on subarrays. I'll just solve one question on subarray that will clear your entire fundamentals on subarrays. Okay, break. Chalo, 15 minutes break. Quickly come back, have your dinner. Yes, subarray, subtraction, addition. These three questions I'll solve after break. But for that, you need to come up after break. There is no pointers. There is no pointers in Java. So there is no such pointer concept. So that eases our theory little bit. Okay. So quickly come back after break. We'll start with subarrays, subtraction, addition. That two questions we'll solve. Okay. Hello, everyone. Welcome back. Okay, let's continue. I hope you all had your dinner, right? Is this timing like for break works for the people who have dinner in mess? It's fine, right? You get time, sufficient time to have your dinner. No one remains hungry, right? Okay. More than enough. Okay, then that's completely fine. Okay, so let's start with subarrays. Okay, so what is subarray? Subarray is basically a continuous part of array. Okay. Okay, so what is a continuous part of array? So let's say we have a array. Okay, and we have something like 1, 2, 4, 6, 2, 4, 8. Okay, so let's say this is a array that is given to us. Now, we also have a length. Let's say we find out this length. Again. Now, what is a subarray? Subarray is basically any continuous part of this array. So these 3 elements together is a subarray. This 4 elements together is a subarray, right? This entire array put together is a subarray. Okay. So subarray is basically a continuous part of array with the smallest size of 1 and the largest size being the entire array. Okay. Okay. So now, is this a subarray 2, 4, 2, 4? So is this okay? Let me give you examples. So 2, 4, 6. This is a subarray. This is valid. This is correct. Okay. This is a valid subarray. 2, 4, 2, 4, 6, 2, 4. Is this a valid subarray? Yes, this is also a valid subarray. Okay. What else? So is, let's say, is 3 a valid subarray? Yes, this is also a valid subarray. But what if is this a valid subarray? 2, 4, 2, 4. No, this is not a valid subarray because this is not continuous, right? This is not continuous. There is a element in between 6 which we skipped. So if you skip elements, that is not a continuous subarray. Right? If you take 3 elements, even though they are in the correct order, that is not a subarray. Okay, this is not a subarray. This is known as subsequence. Okay. So this is known as actually subsequence. So this is a part of array, not continuous, but in order of the array. So for example, you can pick 3 numbers, 4 numbers in the same order from the array. So that is a subsequence. So for example, 2, 4, 6. Any subarray is a subsequence that is always given. So any subarray is a subsequence, but any subsequence is not a subarray. Excuse me. Yeah. So any subarray is a subsequence. Yes, but any subsequence is not a subarray, right? So subsequence basically says it just has to be in the order of array, right? And the numbers are from array. So for example, this is a subsequence. This is not a subarray. This is in the same order of the array, and all the elements are picked from the array, right? So this is a valid subsequence. But in order to be a subarray, they have to be consecutive. They have to be a continuous part of this array. Okay, understood? And these all are subarrays. Let me give you examples of this. So this is a subsequence. Now similarly, you can take any consecutive part is always a subsequence. 2, 4, 6 is always a subsequence, right? Any non-consecutive part, for example, 1, 3 is a subsequence. Okay. 2, 4, 1, 2, 4, no, not in the reverse order, right? So reverse order doesn't follow. So it has to be in the same order as in array. Right? That's what I mentioned, order of the array, but in the order of the array, right? So 2, 4, 1 is not in the order of array. So you cannot pick 3 elements from array and say that it is a subsequence. No, it is not, because they don't follow the order. So both subarrays and subsequence, they follow the order in array, right? And only thing is subarrays are consecutive, they are continuous. Subsequence is not continuous. They can be like any 2, 3 numbers from the arrays. Okay. 2, 4, 6 is not a subarray. 2, 4, 6 is a valid subarray. 2, 4, 6 is a valid subarray. Yes, this is a valid subarray. So I mentioned this is a subarray. So any subarray is also a subsequence. So all subarrays are subsequence, right? So all subarrays are by default subsequence. Okay. Okay, I've written it not continuous. Part of array Okay, let me write it correct. May or may not. Okay, be continuous. Okay, so it can be continuous, it cannot be continuous as well. For example, so 6, 2, 3, this is a subsequence. Okay, it is not a subarray. Okay. So this is valid subsequence, right? This is subsequence. So subsequence can be continuous. That's what I'm telling. See, any array, any subarray is a subsequence. Any subarray is a subsequence. Okay, but reverse is not true. Any subsequence is not an subarray. Understood? Now clear? They have to be in order. So for example, 3, 8, 2, this is not a subsequence. This is not a subarray as well. This is nothing. So they are just random 3 numbers from the array. They are neither subarrays. They are not subsequence. Okay, clear? Okay, so for now, we'll not worry about subsequence. That you will study right later. We'll solve questions on that. So if you have 3 random numbers from arrays, so that is known as just a subset of array. Okay, so the last thing that you have is subset. So you would have studied this in school, right? Any numbers, a set of numbers picked from array. Okay, or you can say it as set of numbers picked from array. So this question is to like whatever we are studying. This is the basics of cadence algorithm. I'm going to like explain that only. Okay. So where is on the end of this? I'll explain one question, then I'll explain all the questions of that. Subsets can be any subsets can be in any order. The subsets is just numbers picked from array. They doesn't tell you anything about order. They doesn't tell you anything about. So they are just simply numbers. So it can be in any random order. That's why it is known as subset. A small part of array. Put it in any random order. That is known as subset. Subsequence and subarrays are to be in order. Subsequence can be like two numbers from here, one number from here, one number from the end. That can be a subsequence. Subarrays even is more restrictive. It is like continuous. Okay, so you can think it like most restrictive is subarray, which is continuous. Subsequence is little bit lenient. So it tells you that you can have a small part from here and then some small part from here. That is fine. Subset is still like gives you the entire flexibility. Just take any numbers from array, right? That is a subset. Subset is a random set of the numbers in subset of a array should be from array, right? So for example, you cannot. So for example, if you have a number, let's say, so if this is a valid subset of array 3, 4, 7. This is not a valid subset of array. Why? 3 and 4 are there in array, but there is no 7 in this array. So this is not a valid subset of array. 7, you are picking 7 number from somewhere which is not in array, right? So that is not a valid subset. So subset has to have numbers from arrays. That's the only criteria. Okay, understood? Array, subsequence, subarray, subsequence, subsets. Clear? Now let's start with subarrays. Okay. So what is subarrays? What are the kinds of questions you'll get? So let's do very simple question. Print all subarrays of an array. Okay. So let's say you're given an array and you have to print all the subarrays of an array. Okay. How can we do this? Anyone, any idea, any guesses? So let's think. Okay, let's think together. So let's say 1 is our subarray. This is a valid subarray. Okay. Let's say 1 is going to be a starting point or subarray. Okay, and it ends over here. Okay, so this is also a valid subarray. Then 1 to 4 is also a valid subarray. 1 to 6 is also a valid subarray. 1 to 2 is also a valid subarray. Okay, so one way I can think is if I pick the start point as fixed. Okay, so if I run a loop, that will give me the start point of subarray. So let's call it as a I loop. And what this is going to do, this is going to give me the start of the subarray. Okay, this is going to tell me the start of the subarray. Okay. Okay. Inside this, okay, so I is nothing but the start of subarray. Now, what I need else? So I need the end of the subarray, right? For example, if it is ending over here, so this is the end of subarray. If it is ending over here, that means this is the end of subarray. So I need one more loop that will be end of subarray. So let's say if my I start, so if let's say this is the start position, what can be the end, what can be the index of the end locations of the array? I to n. So j can be simply I, and we can go to n and j plus plus, right? So I is the start of the subarray, j is the end of the subarray. Okay. Last thing, so we got the start index, we got the end index. Can we print all the subarrays? Yes. Where is the subarray starting? I. Where is it ending? It is ending at equals to j. And we can increase k. And let's just print this. System.out.print. Let's say a of k. And after printing each subarray, we'll just print a new line. Now look, I've written 3 nested loops. For now, let's not worry about time and all those things. Okay, we'll optimize it. See. So what this is, oh, I've not given space. Let me run this again. See, so the first loop is picking the start point. Okay, so I pick the start point is I, which is 0. Okay, just look up how this runs. You do a quick dry run, you'll get the idea. Time will exceed. It's definitely going to exceed for 3 loops. That's why we'll try to optimize it, right? So firstly, I started with I equals to 0. I told that this is the starting point. Now, what is the ending point? So ending point, I told that j is equals to I. So j is equals to 0. J started with 0 and it is going to n. So my I is fixed. My j would vary from 0 to n. Okay. Now, what is k doing? K is just telling that, okay, I got the starting to ending. So firstly, I got 0 to 0, which is this. It is printing, right? 0 to 0, it is running the loop. It is printing a of k. Okay, simple one value. We change the line. Next iteration, I is still 0, but j changed to 1. So 0 to 1 is the next subarray. So it is printing 1, 2. Next subarray is 0 to 2. So it is printing 1, 2, 4. Next subarray is 0 to 3. So it is printing 1, 2, 1, 2, 3. Okay, 1, 2, 0, 1, 2, 3. Okay. Same with then 0 to 4, 0 to 5, and we see all the values. Okay. Now, once j reaches n, we end this loop and we increase I. Now, what I'm telling, my start index has increased. Now start index has increased. So this time we are changing j. J runs from 1 to n. So now my subarrays are 1 to 1, 1 to 2, 1 to 3. Subset is not continuous. Subset is random numbers. So I need random numbers. Just they have to be from array. That's it. That's the only criteria to be a subset. Okay. 1 to 4, 1 to 5, 1 to 6. Okay, so on. So you'll see all the second subarrays, the second set of subarrays that you are seeing is starting from 2. So we have 2, 2, 4, 2, 4, 6, 2, 4, 6, 2, 2, 4, 6, and up till end, right? So 2, 2 till here, right? Whatever subarrays we had, we got all the subarrays. Acha. Next, we have 4, right? I will change to here. So we'll start with 4 and we'll print all the subarrays starting from 4. Then we'll print all the subarrays starting from 6 and so on. And finally, we'll get all the subarrays that we use, right? So we finally have all the subarrays starting from 8. So 8 and 8, 3. And then only subarrays that start from 3 is 3. We get 3 at the end. So this gives us all the subarrays that we have for this given particular array. Let me maximize the screen so I get some extra space. Okay, clear? We cannot print using j loop, right? So if you want to print all these subarrays actually differently, we cannot print it using j loop. I think you will not be able to print, right? So j will simply print 1, 1. So you'll see this. You'll simply see this. If you print I to j, you'll firstly see this, then you'll see from 2 to n, right? If you print it in the same line, you can print every new number. So for example, if you just skip this and you print, so let's say you are telling this, right? We can print simply j. So if you don't write this loop, start to end point, see what you will see is, see. So 1, 2, so this is like the first, so 1, then 1, 2, then 1, 2, 4, then 1, 2, 4, 6, right? So you have to take them separately, right? 1, 2, 4, 6, 4, so on. So you'll understand, okay, till here, this is the first subarray. J plus 1, that's not required because I to I is a valid subarray, right? 0 to 0 is a valid subarray. A subarray of length 1 is valid, right? Sorry. A subarray of length 1 is a valid subarray, right? So that's why so J is starting from I, because I to I is a valid subarray, that also we have to print. Okay. Understood? The printing of subarray, if I ask you to print all the subarrays, there is 3 nested loop and you cannot like remove any one of the loops. Okay. You cannot do this. There is no optimization that you can apply over here that will work. Okay. Because you need to, so if you are asked to print something, we are doing a minimum number of iteration. We are not doing any additional iteration that you can remove, because this we are just printing this. Like we are not doing anything like after running after it or before it, trying to find out this. No, we are not doing anything else. We're just running for start to end and we are printing the sub. Okay. Clear? Yes, no doubts? No, not clear or clear, no doubts. Clear. Okay. Okay. Now, will you just get the question to print it? K loop, J and K loop? Yes. So see, J loop is picking the end index. Okay, so we pick the start index using I loop. I loop हमें बता रहा है. So start index is going to be this. First iteration, then start index is going to be this. So start index is going to be this. Now let's say pick any start index. Let's say this is the start index. What is the end index? So end index of any, what are the subarrays starting from 2? So there are actually a lot of subarrays starting from 2. So 2 is a subarray itself. 2, 4 is a subarray. 2, 4, 6. Now similarly, you can get 2, 4, 6, 2, or you can get 2, 4, 6, 2, 4, so on. Right? So you can keep on expanding this, that will give you even a larger subarray. So these are all the subarrays that start with 2. So what I've done, I picked the start point, which is I equals to 1. I've told that how the endpoint is varying. Endpoint will be firstly I, then I plus 1, then I plus 2, I plus 3, I plus 4, and so on. Right? That's how it's going to vary. So J is changing. J is firstly I, then J changes to J plus 1, J plus 2, J plus 3, J plus 4, and so on. Right? We print that subarray for every start and end point, which our scale loop is starting from I, which is the start point, ending at J, which is our end point. If we want to change something in the subarray and print the original subarray, it will change the array, right? If you change in this array, that will reflect it, right? So see, I'm just printing it. This is just a like thinking wise, it is different. Arrays, I am not created any multiple arrays. These are not these many arrays. I do not create any array. I've just printed the array in some pattern, right? So this is just printing array. I did not create these many subarrays. I just printed them. I did not actually create multiple subarrays which are storing this. Multiple arrays which are showing it. No, I've just printed it, right? Just using the same array to print it. No copies, nothing. This does not exist. These are the same array. If you update this A of something, that will update the same array. There is no copy of it. Okay. Understood? Yes. Let me show you some questions. Don't worry, like I know this might look like a little bit overwhelming. Let's solve a few questions. It will get useful. Okay. So let's say we want to find the sum of all subarrays. Okay. We want to find out the sum of all subarrays. So these are all the subarrays that we have. What we can do. So let's say we have to print the sum subarrays and the sum as well. Okay. Now tell me one thing. Where do you need to initialize your sum 0 and where do you need to update it? Tell me the line number. So should I do a sum equals to 0 outside and then I increase it every subarray? No. The place where our subarray starts, where is this? So I'm printing it over here. So let's take the sum as 0. Again, sum equals to 0. Okay. What I can do is I printed the entire subarray. I printed the subarray. That point of time, whenever I'm printing the subarray, I can also find the sum. Okay. Sum plus is equals to A of k. Now we got the sum and we can also print this system.out.println. Oh, let's print it, right? Let's just print it sum. Okay. Why do we need two things, right? We can just print system.out.println sum. Yes. Now look at this. So when I run this, what it is going to do? So every time it is printing this subarray, we are also finding out the sum. So it is telling the sum of this subarray is 1, the sum of this subarray is 3, the sum of this subarray is 7, the sum of this subarray is 13, the sum of this subarray is 15, this is 19, this is 27, this is 30. Right? So every time we are printing some subarray, we are taking a variable 0. We are finding out the sum of that subarray. And after like this loop ends, we'll have that subarray sum. So we are printing. Okay, understood? How we are getting the sum of all the subarrays? Yes, no? So let me do one more thing as well. We'll show you a little bit more interesting way. Yes, this code is not optimized, right? We can optimize it. For like here, we are asked to print the subarrays, so we cannot optimize. Let's say if I ask you to print all the subarrays, if I ask you to print, there is no other way, right? If I ask to print the subarrays, so you need to write 3 loops, right? You cannot skip any one of the loops, and you will get all the subarrays. You cannot get all these subarrays, right? This loop is required, right? So this K loop is basically printing each line, right? For each line we are printing. I loop is running for the number of lines. Okay. I loop is running for I loop is actually not running for the number of lines. I loop is having this. So for these many rows, I is value is singly 0. Okay. J value is changing. J value is printing the number of lines for I equals to 0. And then we are seeing K loop is printing each row's value. Each row's value K loop is. See, so basically this is the subarray 0 to 0. This is the subarray 0 to 1. Now you take any example from it. Let's say this is a subarray which is 0 to 6, which means the index from 0 to index 6. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Yeah. So this is the subarray. See, so 1 to 8 is the subarray. The sum is 27 and the index is from 0 to 6. Right? So this list gives you all the subarrays, all their sums, and all the indexes of all these subarrays where they are present. Okay, understood? Yes. Okay, clear? This part. So earlier we were just printing it. Now we have added one layer to find out that sum, print the subarrays along with the sum, and also print the index as well. Right. So this is like you can remove the index if this is looking more complicated. Right now we are just printing the subarrays along with their sums. Okay, for easy understanding. Understood what's the use of K loop? So K loop is basically printing each subarrays, right? Each subarray is printed by K loop. If you just print by J, you won't get these two lines. See, you can't get these two things. J will print till here, and then next iteration J value is 4, 5, right? So it will just give you this value. So how will you print this thing again? That is done by K loop. Okay. Now we got this. So is this going to be the question? No. Like the question is a little bit different. Sum of subarray size, and I'll come to that question. That is like easy. I'll show you even a difficult version of that. Okay. So let's say there is a very famous question which is known as maximum subarray sum. Okay. So you have to find out the sum, right? We have to find out the subarray sum which is maximum. So out of this, let's say you have so many subarrays, right? So you are getting so many sums. Now, out of these sums, which sum is the maximum? So you'll say, this is very easy, right? The largest sum, the largest size subarray will have always the maximum sum, right? So that is just the sum of entire array, right? But it doesn't work that way, right? What if the array numbers are negative? So if the array numbers are negative, then you won't get the entire array sum as the maximum subarray sum. So for example, if there are negative numbers, now try to find out the entire subarray sum. It is entire array sum. It is going to be lesser if you just take this subarray. 8, 3, it is going to give you 11. So this sum is going to be highest. I guess so, yeah. Okay. So you can have negative numbers as well, and in that situation, your maximum subarray sum will be the actual subarray sum of some subarray, right? Okay. Okay, so we have a array which can have negative numbers as well. And then we have to find out the subarray which has the maximum sum. So this is also easy, I'll say. E part is easy if you just do by this logic. Acha. Let's say you have a list of, you find out the sums. Can you find out the maximum sum among them? So we don't need to print these subarrays. We can remove this logic. You don't need to print the sums as well. So you can remove this logic. No DP, nothing. See. So what we are doing is we are finding out the subarray sums. So after this loop completes, what you are going to get? You are going to get the sum of subarray, right? Now, for which subarrays we are doing this? We are doing it for every subarray of the array. Now, if you just find out the maximum among this sum, we are going to get our maximum, right? So how do we find out maximum among something? So we can take integer dot min value. Okay. Let's assume our maximum is integer dot min value. The sum that you find out, if it is greater than max, then we can store the maximum is equal to sum. At the end, if I just print it, print this maximum, is it going to give me the maximum subarray sum? Okay. We are getting 11, right? Now, how is this working? So what we are doing is, for every subarray, we are just trying to find out the sum. So we are going through the entire subarray. We are finding out the sum, and then we are checking if the sum is greater than maximum. Yes, then it is the new maximum. So that is what we are printing. If this sum is not greater than max, then it is not like the maximum. So we don't print it. I'll come to that specific size. I'll come to that. That is very easy. That compared to this, that question is very easy. The question that I'm trying to solve. Right. So here you have variable size. Fixed size is even easier than this. Like I'll explain you that at the end. What you can do for fixed size subarray. If let's say the subarray size is given 4, 5, or any k size. Okay. I need to find out which subarray sum of this k size array is going to be maximum. That I'll tell you for a generic one. Okay. First, let's complete this one. Understood this? How is this giving you the maximum result? So we are finding out the sum of all subarrays, and then we are checking, is it greater than max? Then that is our new maximum. If we find out any sum which is even greater than the current max that we found out, so we store that as the maximum. Okay. Finally, whatever result we'll get, that is our final maximum. Understood this one, this approach? Yes, no doubts? Going overhead. Clear? So let's also try to find out. Okay, now we found out the maximum. Can we find out the subarray as well? If I give you one simple thing to find out the subarray, how will you find out it? Think बहुत easy है, very easy. We have done that in if I tell you to find out the maximum, so maximum value, and if I tell you to find out the index of that maximum number, how did you do? So store the ing, right? So we don't even need a temporary array. So you can just take two values. Let's call it as start, which is -1, and end, which is also -1. Okay. So you just need to store start is equal to 0, and end is equal to, sorry, start is equal to I, and end is equal to j. Right, done. After this, you just need to print this index. If you want to print the array, that also you can do. Okay. If I run this, it is going to tell me that this is our maximum and this is the index of this. Oh, sorry. Start and end. Okay. So it is telling that this is the maximum subarray sum, and the index of that maximum is 6 to 7, which is 8 and 3. Okay. Now, if you vary this, let's make this as positive number. Okay, so now the maximum subarray sum is this 4 index values, right? 8, 3, 11, 12, 13, 13, 4, 17. So you should see 17. Now you can try out all the other subarrays. That will be lesser. So this is like the maximum subarray sum that we are going to get from here. 17 index 4 to 7. Right. If you are not asked to print the index, if you are asked to print the array, so you can print the array, right? From, if you know the start index and if you know the end index, from where to where you have to print in the array. So you can run a loop simply to print the that part of the array, right? So this array you can easily print system.out.print a of I. So this is your sub array. Okay. You just need to run a loop from the start to the end index, and you can print the same array. Understood? So we get this array. Easy. So we found out all the sums, we checked out of these sums which one is greater, and then we stored it. If we want to print that sub array, we store the indexes. Every time we are finding that maximum, we store the start and end index. And then we told, okay, since we got the start and end index, this is our start and index. If we want to print that sub array, we can print any part of the array, like from any I to j index. So you can print that, right? You don't necessarily always need to print the array from 0 to n. You can print from 1 to n, 2 to n, 5 to 7, 3 to 8, or any part of array. If you want to print, you can print it, right? That you can. Okay. Huh. Now, is this the best solution that we have? No, this is nowhere close to the best. What's the time complexity of this logic? So, let's see. So this is order n. Okay, let's ignore that. So this is order n. This is again order n, and this is again order n, right? So it is n cube in worst case. Right? If you try to see, this is three order n loops approximately. So it is n cube. Now, this is a very bad time complexity. This won't even work for 1000, right? If you have ns 10 to the power 3, which is 1000 size array, this logic is not going to work, right? So now here I'll show you how you can think through of a solution from a very bad code, how you can think of optimizing it. Okay. So see this approach very carefully, and this is always going to be your approach. See, 90% of the time you're not going to like know the optimal solution in the interview when you get the question. You will write some code that is n cube, n square or something, and then you will optimize it. Okay. So let's look what we are doing. Okay, let's try to observe. Let's try to make some observation. So what is this scale loop doing? So what we are doing is we are trying to start from I. So this is our first subarray. What is our second subarray? This. What is our third subarray? This. What is our fourth subarray? This. What is our fifth subarray? This. What is our sixth subarray? This. Okay, and so on. So every time we are just adding one new number to our subarray, and that's create a new subarray. Okay. I'll explain cadence algorithm. This is where I'm going to cadence algorithm. This you need to understand this to understand cadence. Okay. See. So what we are doing is we are adding one new numbers, but how we are finding out sum. So firstly, I am finding k loop. I am running from 1 to 1. Then I'm running from 1 to 2. Then k loop is running from 1 to minus 4. Then 1 to minus 4 minus 6. Or 1 2 minus 4 minus 6 2. We don't need to print the arrays. Okay? Keep in mind, we are not required to print arrays. We just need to find out that maximum sum. So here, tell me one thing, how is these two sums differing? We just added, if you just add 2 to the previous sum, will you get the this sum? Or if you just add minus 4 to the previous sum, will you get this sum? If you just add minus 6 to the previous sum, you will get this sum. Or if you just add 2 to this previous sum, you will get this sum. So every time you are adding these new numbers into the array, you just need to add it to the previous sum and you will get the new sum. Yes. So we don't need to run this scale loop actually, and we can still find out that sum. Okay. Now look at this, how we are trying to solve this. See, so this is just an observation that we made over here. So what we saw over here was this scale loop is running for multiple times unnecessarily. Right. So if we know the previous sum, we are just adding one. So for example, previously, let's say I is running from 0 to 5. Next time k loop runs, it is going to run from 0 to 6. Right. So let's say first, like once for the k loop ran from 0 to 5. Next iteration k loop is going to run from 0 to 6. J is just going to increase by 1. I is fixed. So whatever is the sum of 0 to 5, if you just add a of 6 to this, whatever is this sum, let's say you have sum, if you just add a of 6, you are going to get this sum. We don't need to run from again 0 to 6 to find this sum out, right? So you can use the previous sum and add just a of 6 to it. How can we do this in code? In code wise, it is very easy, right? Like theoretically, first tell me, did you understand this concept? Ye samajh aaya? So basically you have the sum already. You just need to add a of j to it. Instead of what we are doing, we already have the sum 0 to 5. Instead of just adding a of 6, we are going again from 0 to 6 to find that sum, which should not be there. We should try to think something better, right? We should do some better coding over here. So what we can do instead of doing this, okay, let me copy this entire thing. Copy this, comment it out, paste it. Okay, so I'm writing all the logic so you can see how it's varying. So we don't need this k loop, so that's not required. We can just move this statement out outside. Okay, And what we need to do is every time we take a new number, we just need to do sum is equal to sum plus a of j. We just need to add a of j and we'll check if the sum is greater than max, then okay, this is our start index, this is our end index, and that. Okay. So previously, what was the result that we are getting? It was 17, 4 to 7. Now, if let's try to run this, are we getting the 7 result? Let's check. See, 17, 4 to 7, 2, 4, 8, 3. Same subarray, same result. What did we do? How to move the code to the upper line? Alt arrow, that works, right? Just keep your control anywhere and press alt arrow, that moves the code. Okay. Alt plus arrow keys, that will move the code. Control plus slash, that will comment out. Okay. Now see this. So what we are doing over here is, okay, firstly tell me how many of you understood this, how many of you have doubts on this. Can I explain this? किसी को भी समझ आया कि how did we do this? What this? A little confusion. Chalo, let me explain that. Okay. See, what we are doing here is earlier, let's say we had 0 to 5 array, and then the next subarray is 0 to 6, and next is 0 to 7. What we were actually doing is the K loop was running from 0 to 5, then K loop was again running from 0 to 6, K loop is again running from 0 to 7. Achha. And we are finding out the sum. This was giving us the sum. Instead, what I told that don't do this approach, this is very lazy. If you have the sum from 0 to 5 and you want to find out the sum from 0 to 6, what you need to do is, you already have this sum, just add a of 6 to it. Now you'll get the sum, new sum, whatever is the sum that you got over here. Just add a of 7, you'll get the next sum. So you don't need to run this K loop altogether. You just need to keep the track of previous sums. How did we do it? See. So whenever we are starting a subarray, which is I equals to 0, we are starting the subarray. So I told let's start with sum equals to 0 over here. I think I is pointing over here. Let's tell the sum is starting from 0. Now j is over here. J is equals to I, so j is over here. So we add inside this j loop, we add sum plus this. So sum changes from 0 plus 1. We added this one. Okay. Now j changed to here. Next iteration, we checked it is greater than max, so that we'll store it. Next iteration, we'll check, add 2 to it, so it becomes 3. See, now what we did, firstly it stored the sum of subarray 1. Now it is storing the sum of subarray 1, 2. Without iterating through 1, 2, we just found out the sum. Next iteration will again, j will come to here. We'll add -4 to this, so it becomes -1. So we get the sum of subarray 1, 2, -4 without iterating through the array. Because we are adding this just new number, we just added it to our sum. If it is greater than max, we'll store it into our result. Now the j changed to here, we add -6. So the sum becomes -7. Okay. So we found out the sum of this particular subarray without even going through all the numbers, right? Again, j changed to here, we added 2 to it, became -5. So the sum of this subarray is -5. Works? Now understood how is this giving you the sum? Now, is this better? Now, yesterday I told you, right? Now, since you know about time, you can compare whether which one of the logic is better. So earlier, the time complexity that you were getting is n cube, right? Over here, you were getting n cube, right? Over here, what you are getting is n square. Now it is same, it is better, right? In the previous logic, n cube from n square is better than the previous one. Can we even better it? Yes. And that is what cadence algorithm is. Okay, so okay, this is our logic. So I'll write cadence from scratch because you need to know, understand it. So let me copy this just there. For printing, if I ask you to print all the subarrays, then you need 3 loops, right? And that will be not the scenarios. You'll not get questions like print all the subarrays because that is n cube, right? There is no optimizations that you can do, right? So printing is not cannot be optimized, but finding out the sum of a given like part of array. Let's say a subarray size is given 2, 4 something, and you have to find out which sum of this is going to have the largest sum. Which subarray among this is going to have the largest sum. Here you can find out the product of subarray. Okay, or you can find out how many even numbers are there in a subarray. So tell me the subarray, count the subarray which has the highest number of even numbers, or count the subarray which has highest number of positive numbers. So Same logic, right? Every subarray you just need to count it. So this is going to work for any such sum, count, multiply, this n square logic, right? N square logic is if I tell you to count. So let me write a few questions over here that you can solve. So this is maximum subarray sum. Now we can solve questions like count the number of even numbers in each subarray. You can use the previous count, right, for every subarray that you're expanding. Count prime numbers in each subarray or something like that. Find find the maximum product subarray. Okay, similar to this. Okay. Now, okay, we understood from how we optimized from n cube to n square. We just observed something into the array that we were doing. See, the way to think of how to optimize a code is always to think from the innermost loop. The operation that you are doing in the innermost loop has the highest chance of being redundant, has the highest chance that it can be optimized. Okay. So we just saw what is the operation that we are doing over here. So this is finding out the subarray sum from 0 to 5, 0 to 6, and 0 to 7, and so on. So we saw that this operation is getting repeated again and again, and we can use the result of previous operation, right? So we remove this loop. So always try to look for the innermost loop, because that has the highest chance of getting doing some operation which you can get the result otherwise as well, right, without running that loop, right? So that is the best way to think of optimizing. Now here, what we are doing, okay, so same way, let's say, can we optimize it even further? So what will be better than n square? Order n, right? Now, how can we optimize it to order n? So let's check what is the operation that we are doing over here. So we're finding out the subarray sum of each subarray. So here also we are finding out subarray sum of each subarray, right? Each subarray sum we are finding out, right? So we are finding out subarray sum of this. Every subarray that we have in the array will find out the sum of them, right? That is what this loop is doing. So we are going through all the numbers and finding out the subarray sum. Now, is there anything else that we can think of instead of finding all the subarray sum? So there is actually. Achha. So what is that? So let's say, so you start to find out the subarray sum. So you found out the subarray sum of 1. So you got the sum as 1. Then you add 2 to it. So your subarray sum becomes 3. Okay. Till here it is fine. This can still be the largest one. Now, when you add 4 to it, or minus 4 to it actually, so the subarray sum becomes minus 1. Now here, look at one thing. So once the subarray sum becomes minus, right, once it becomes negative number, right, no matter if you keep on expanding this subarray, right, even if 6 was positive, right, let's say if 6 is positive, right, so let's assume 6 is positive. So tell me one thing. So this subarray has a sum of minus 1. If you try to find out this entire subarray as well, is it going to have a lesser sum or a greater sum? Instead, if you just take this subarray, so this subarray is always going to have a greater sum, because this subarray is giving you a negative value. This addition of these numbers into the subarray is making a negative contribution than a positive contribution. So the sum is going to decrease instead of increasing, right? Because these three numbers are sums are negative. The sum of these three number is negative. This subarray. Now, if you join these two subarrays, right? I'll talk about what if all the numbers are negative. I'll talk about that situation, how that will get handled. Now, let's think of there is at least one positive. Okay. Yes. So there is at least one positive number. Sorry, someone was saying something. I muted everyone. Okay. Okay. See. So, okay. So if the subarray is contributing a negative sum, then we'll say, okay, let's stop over here. There is no point of taking this sum forward, because this will anyways reduce the sum of the later part. Okay. So let's stop here and let's start fresh from here. If we just start fresh from here, we'll still get a higher sum. If we just take this number, which is positive, it will give us a higher sum instead of taking this entire array, because this previous part is contributing negatively to the sum. So it cannot increase the sum in any way. Okay, understood this observation? So basically, if you keep on adding numbers and the sub-array sum becomes negative, that point you can say stop. Let's stop over here. We can start fresh because till here whatever sum we got, that's fine. This is not going to make a positive contribution. We can start again from 0 and we can check. Okay, so we'll check, right? If the first and second numbers are too big, then we'll check for every time we find out a sum, we'll check whether it is. So let's say if this is 100, 200, right? So this, let's say this is 100, 200. So the largest sub-array sum is 100, 200, right? And okay, so now see, if these two numbers are positive, so okay, that is not the actually largest sum. So now if these two numbers are positive, adding this -4 will not make the sum negative, right? This is not making the sum negative. This is still like 296. So this is still a positive number. So this is contributing positively to the sum. So you can keep on expanding it. Now the largest sub-array sum is actually this, right? But here, let's say if the number was 400 over here, okay, now what would happen? No matter the first two numbers are larger, this, if you take this sum, okay, so these two gave us the sum 300, which is the largest sum. Now if you add this sum becomes -100. Now if you take this -100 forward, you are going to get a lesser value. Instead, if you just take 6, if you just add -100 plus 6, that you are going to get 94, but -94. But if you just take 6, you are better off having a larger sum. So we'll just start with 6. So earlier we got 300 as the sum, right? Here we got -100, then we got 6. We'll check, right? Which one is the maximum? Okay. The logic of this is very simple, and this is the entire concept. First, tell me, did you get a little bit of idea about what I'm talking? थोड़ा सा भी कुछ idea लगा? Yes. So basically, if you just try to sum up numbers and your sum becomes negative, it is anyways going to contribute negatively going forward. So you'd say, let's stop over here, let's start fresh. Okay. So let's say we'll take a sum which is 0. Okay. And let's check, let's take a maximum which is like integer dot min value. Same. Okay. So what we'll do is we'll run a loop for int I equals to 0, I is less than n, I plus plus. Every iteration, what we are going to do is we are going to do sum is equals to sum plus a of I. Till here, it's fine. Now, what I'm going to tell is if, okay, we'll check if the sum has become greater than maximum, then this is the maximum sum, right? So this we can tell is the maximum. Okay. If the sum has not become greater than maximum, then whatever maximum we have, that is our maximum. Okay. So, apart from this, we'll check one more thing. If the sum has become negative, if the sum has become less than 0, that means the sum is negative, then we can say, okay, sum has become negative. There is no point of carrying this forward. So let's start fresh from the next number and let's start with sum equals to 0. Okay. Now let's, after this loop ends, let's just try to print the maximum value that we have. So previously we were getting the maximum sub-array sum is 17, and we had this as -6, right? Let's try to run this and check. They're getting 17. Same solution. Okay, we'll print about the sub-arrays as well. Let's first check how is this logic working. Just check. So firstly, we took sum is equals to 0. Okay. I is equals to 1. I is equals to 0. Okay. I added a of I, which is 1 to the sum. So sum became 1. Is 1 greater than integer dot min value? So maximum was equals to -infinity. So 1 changed, this changed to 1. Okay. Is sum less than 0? No. So we don't do anything. Next iteration. We got 2, I is equals to 1. So the value that we got in index 1 is 2. So we add it to the sum becomes 3. Is sum greater than maximum? Yes, sum is greater than the maximum. So we store 3 into the maximum. Done. We check is sum less than 0? No. We don't do anything. Next iteration. I equals to 2. The value that we get is -4. So -4 plus 3, it becomes -1. Is -1 greater than max? No. We already have a sub-array which is giving us the sum 3. So this is not greater. So we'll not take this one. We already have a greater one. So maximum will be still 3. Okay. Now we check, is the sum less than 0? Yes, sum is less than 0. So there is no point of taking this forward. We can start from a fresh sum next one. So we'll just change sum to 0 over here. Okay. Next iteration, I equals to 3. So I equals to 3 is -6. So we add -6 to it, it becomes -6. Now, is -6 greater than max? No, we are better off taking 3 than taking this negative. So we'll just take 3. We'll check is sum less than 0. Yes. So you don't need to take -6 forward as well. We can just simply make it 0. Okay. Next iteration, I changes to 4. We get 2. So we add 2 to it. So is 2 greater than max? No. Is 2 less than 0? No. Next iteration, I changes to 5. We get 4. Now we add 4 to 2. It becomes 6. Is 6 greater than max? Yes. So this sub-array sum 4, 6 is greater than the previous sub-array sum that we got. We'll change max to 6. Okay. I value increases to 6. We get 8. So 8 plus 6 is 14. Is 14 greater than max? Yes. We change it to 14. So this is the new sub-array sum. That is the maximum. Is it less than 0? No. So we don't do anything. Next sub-array that we found out is index 7. So this we added 14 plus 3, which is 17. And we change this value to 17. Is it less than 0? No. So finally we get the maximum as 17. Understood? So basically we started from the start, and this is a pure observation concept, right? This is one of such algorithm that is completely observation derived. So there is like no such logic to it. It is just observation that you can make. So if we start from starting and you keep on adding numbers, if you get positive sum, that's fine. If this is number is, let's say 10 or 20, right? So we would have got, so if this number was 10 or 20, we would have, like, even if you add this, you get a positive number. So keep on carrying this forward. If you add -6 as well, you get a positive number. So you keep on carrying this sum forward. So you finally get the entire subarray as the largest sum, right? Because adding 20 to this still gives you the larger value, and adding these makes it even larger. Okay, understood? Now, does it work for all negative numbers? Actually, it works for all negative numbers. So what you are going to get for all negative numbers, you know? So for all negative numbers, what's going to happen? Just take a look. So for all negative numbers, what you are going to do is, we are going to just find out the sum plus a of I. So we are going to add sum is equals to sum plus a of I. So we are just going to add -1. We check is -1 greater than max? Yes, it is greater than max. Maximum is integer dot min value, which is -infinity. Any number is greater than this. So we store the max as -1. Okay. Next we check is sum less than 0. Yes. So we start with 0 again. Next we add -2. So basically what you'll end up doing is, you'll just end up comparing, is -1 greater than max? Is -2 greater than max? Is -4 greater than max? So you are basically finding out the maximum in the array, which is fine. The maximum in the array is the sum of the maximum subarray sum. So you're getting -1, which is fine. This is the largest subarray sum you can get from here. If you add it with any other thing, that subarray sum is lesser. So the largest subarray sum is -1, which is fine. Okay. So this concept also works for the array having all negative numbers as well. Understood? Is that yes?
What
Okay.
about the starting and ending?
Starting and ending, yes. I'll talk about that. Yes. So this algorithm is known as cadence algorithm. So this algorithm's name is cadence algorithm. Okay. Now, how do we find out the starting and ending index over here? So see, let's again take the same thing. And start is equals to, let's say -1, and end is also equals to -1. Okay. So what is the end over here? So whenever you're updating max, so you know the end, right? What is the end? End is I. Yes. End is I. The only problem is we don't know the start. We don't know the start here, that how is the start changing? Where is the start? So let's do one thing. So before starting the loop, I just mark the start as 0. That means I'm starting with 0. Okay. If I ever enter, if I don't enter this, my start point is 0, and I just keep on adding numbers, and my maximum is changing, and just keep on changing the end index. Okay. So let's say if all the numbers are positive, I just keep on getting maximum, higher values. So I just keep on adding numbers, and my end index is changing. Start is 0. Where is my start index changing? When is my start index going to change? My start index is going to change if your sum becomes negative.
When sum 0.
Yes. So here we are going to change start is equals to the I. So if I, start is equals to I plus 1. So for start is just going to be I plus 1. So that start is the next index. Achha. Okay. So you'll get a start and you'll get an end index. Now there is one catch over here. Okay. So Acha, tell me, you will get the correct end index. Will you get the correct start index by this logic? No. Why will we not get the correct start index? Index out of bounds, no. So for example, let's say we got the maximum already, right? So for example, let's say here we got the maximum already. Let's say it's something like 40, because this we got the maximum already. Okay. Now this is this we got the maximum. So here, like if I run this, so let me just not print that. So if I run this, your maximum subarray sum is 43, right? This part. Okay. So if we got this sum as 43, your end index is going to come out. Okay, let me just print this. So let's just print start and let's just print end. Okay, let's run this. See, your end index you're getting correct, which is 2, but start index is not correct. You're getting start index as 4. Why are you getting start index as 4? Because once we found out this, we again kept on adding numbers, right? We did not knew that this was maximum. So we could have got a higher number, but we did not get. So we got a negative, which became -20, and that point of time we changed our start. Okay, and our start changed over here, and then finally we got 4 as the start, and like our end index is over here. So how can we handle this situation? How can we get the correct start index? Any idea? No. Let's take a final start, which is -1. Okay, whenever we are storing the end index, we can also store the start index. Okay, which is the current start. So whatever start index we will have at this point of time, whenever we found out this maximum, we store that start index, we store the end index, and at the end we'll print this final start index, not the start. So this start might have a different index, but this will be correct always. Okay, because this is only getting changed whenever we find out the maximum, when we are updating this maximum. So now you're seeing this is 0 to 2, which is correct. I know this is a little bit confusing. Yes. So let me explain you this. See, so let's take this example. Okay, so end index was fine, right? End index was, there is no complication. We took two variables, one is start and one is end. Let me just do a let's go back to the try run. This one. Okay, so let's take I equals to 0. Okay, I do sum is equals to sum plus I, so I do sum is equals to sum plus 1, so sum we got as 1. Okay, start is, what is start, what is end, and what is this? So this is 0, this is -1, this is 1, -1. Okay, this is till now we have not changed it. Now we got sum is 1. What we are doing is we are storing maximum is sum. Maximum is sum is greater than maximum. So store the maximum is 1. We change the final start index. Final start index is equals to 0, and the end index is equals to current index is 0. Okay. So these two things will always update every time we are updating max. So every time we'll update max, we'll also update the start and the end index. That this is the start and this is the end index. Okay. Now see, next iteration I becomes 1. We add 2 to it, so it becomes 3. So our sum is maximum is greater, so we tell the maximum is 3. Our start index is still equals to start, which is 0. So start is still 0. Okay, so we start, final start is 0, and index changes to 1. Okay. Next, I changes to 2. Just look at here. So I changes to 2, so it adds 40 to it, so it becomes 43. Now this 43 is greater than max, so we change this maximum to 43. Our start index changes to start index updates to 0, and index updates to 2. Start index updates to start, which is 0, and index updates to I, which is 2. So it index updates to it. Now next iteration, I becomes 3, we add -60 to it. So on adding -60, the sum becomes -70. Now here, is this greater than max? No. We check, is sum less than 0? Yes, sum is less than 0. So we change the sum to 0, and we change the actual start index to I plus 1, which is 4. So we are simply telling the start index is now 4, which is the next place where we are going to start a fresh sum, because we are starting off sum fresh, which updated the start index. Now look here, this is never going to update because the final start is stored as 0 and end is stored as 0. So this start might change, but this will always be corresponding to the subarray for which we have stored the maximum. Okay. Now if I just run write for I equals to 4, we'll get sum is 2, so this will add to 2, which is not greater than max, so this condition will not satisfy. This will also not satisfy, less than 0. We'll get this as 5. So this sum will change to 6, which will not satisfy both of the conditions. Neither it is greater than max, nor it is less than 0. Then I changes to 6, which is 14. I changes to 7, which is 70. So none of these two conditions satisfy. Now let's say if we have a like larger value at the end, okay, we have the sum as 17 that we got over here. The highest that we have is 40. So let's say we have a value 50 over here. Okay, we got the value 50 over here. Now look at this iteration, you'll understand everything. So let's say we at the end we have a value 50. So I change to 8. Okay, you got the value 50. When you add 50 to the sum, what your sum you get the sum as 67. Now check, your sum is actually greater than the max that you were knowing till now. So what you will do is you will update the max, which is 67. You'll update the start index, which is this start, which is 4. You'll update the end index by current I. So now still you are getting the correct start and end index. Your sum is 67, your start is 4, your end is 8. Yes, which is this subarray. Yes. So previously also you are getting the correct. Now also you will get the correct result. Okay. Clear? Now, if you know the start and end index, you can print the subarray. That's easy, right? And this algorithm is known as cadence algorithm, which finds out the sum. It uses a simple technique that if your sum becomes negative, then that is going to negatively contribute if you keep on increasing the subarray. So let's stop the subarray then and there, and let's start for a fresh subarray from the next iteration. Okay. There are multiple variations of this logic, but I find this one is the cleanest one. There is a lot of variations of it is written online. Ones I find very complicated. I somehow wrote this. You might find the similar logic somewhere else, but I'm not sure if I saw it somewhere. This is the cleanest one that I can write, right? Where there is like least checks, just 2 if checks, works for all the negative scenarios and all. Like there are logic which works for only like there should be at least one positive number for it to work. Negative scenarios it handles separately. Max value it has used math.max and all those things that made the logic very complicated. This is very clean and simple, and this is one of the direct questions that you'll get. Find out the maximum subarray sum. So you can start by explaining n cube. You don't need to implement the n cube logic in interview. You just need to like orally tell it. You can start by approaching an n square and then optimize it to a cadence algorithm. Okay. And if you are asked to print the subarray, you can figure out this. Because your end index is going to be fine. It is going to be I. Just the start index you have to update. So you're starting it's 0, and then whenever you find this, you have to update it. And every time you start a new subarray, that then also you update. Now, since I explained so much about subarray and now I gave you so much idea, do this question. I'll not explain this. I told that I'll explain it at the end. Sorry. But this, I expect you, if you try it, you all will be able to solve this. Okay. Let's say I tell you to find out the subarray. Okay. Maximum subarray sum for sum for subarrays of size k, any given size, right? If you are given a size 2, 3, 4, something, so you have to tell. So your size is given, size of subarray is given, your size of subarray is fixed. You are going to just take 3 size subarray. So basically, so you can take this subarray, then you can just take this subarray. You cannot take a 4 size subarray. And out of these 3 size subarrays, you have to just figure out which is the largest subarray sum. Okay. You can immediately think of a like n into k logic. So outer loop will run for n times, inner loop will run for k times. So that is n into k logic, right? Outer loop is running for n, inner loop is running for k times. If k is in the range of n, so that will become n square, right? So that is like normal logic that you can directly come up, but this can also be done in an order n logic. You can now try to think how can you do it in an order n logic. Very easy solution, but yeah, think it through. I give you so much idea about subarray sums. I'll share this code. Okay, go through the cadence logic. Okay, try to solve it yourself. Try to write it multiple times because this is very interesting subarray question that you get directly in interviews. Okay. Yes, I to I plus 3 is the like subarray. That's fine, but that is going to be n square, right? N into k. Sorry, if you run that, if k is 3, right? If k is in the range of n, if k is equals to n minus 2, n minus 1, then your final complexity is n square, right? Which is not fine. I know I promised a lot of things to be done today, but I hope we like did something a lot. See, every time I intend to complete a lot of things, I'm left with something to complete. Okay, that's how vast these concepts are. Okay, so I guess we are utilizing time properly. That's place I don't have any like constraints. I don't have any like negative feedback, like we are not using time. So that's fine. We'll try to, so 2D arrays are not intending to start today. We have a few questions still to discuss, like this addition and sub-array questions, whatever is there, please solve them. Okay, please solve the sub-array questions now. Try to do them. Time and space complexity is any MCQs that if you have is remaining, you can do that. For call by value, call by reference, you can just Google up, right? Call by value. Okay, just Google up, you'll get a lot of links. So I guess this one is Java at point is this is good for Java. So this one I find it a little bit cleaner than other sites, specifically for Java. So, but this is using some object-wala concept. So here it is explained for objects. Yeah, so since that is also applicable for objects, you might see it for written for objects. So that is one problem. Little bit difficult for me to find out. Yeah, you can Google it up. You'll get a definitely Geeks for Geeks article, something. So you can refer to all the concepts that I say. Yes, W3 schools and Geeks for Geeks, I say they are like the best ones. Okay. So Geeks for Geeks, if you get an article on that, that's fine. Only thing is I find is sometimes Geeks for Geeks code wise it is not very up to the mark. Otherwise, Geeks for Geeks is very fine. Refer for X if there is one more one. Too many employees and how will the referral work? So see, if there are too many referrals for any post, right, it's so actually it happens nowadays a lot, right? If there is one posting, like there are hundreds of resumes that come just via referrals. So anyways, referrals resumes are looked first because that has already gone through a pair of eyes. What recruiter sees is that someone has from the company has already seen the resume and he is referring. So he might have like scanned through it and he might have checked whether like this person is eligible for this role, right? So basically, no one is going to refer you for senior engineer. They're just going to tell you that your experience doesn't match, right? But if you apply for software engineer, someone might refer you. So those checks are already gone through. So the recruiter firstly sees the referral ones. Out of the referrals ones, it says so referral still helps, right? Yeah. How to find the length of 2D array? So you can find out the length, a dot length, that will give you the number of rows. And then you can do a of 0 dot length, that is going to give you the number of columns. Yeah, I'll explain this, don't worry. I'll start with 2D arrays, I'll explain this concept. Okay, so this is like the rows, this is the number of columns. I guess we might need one more class before starting 2D arrays, not that I can't do. Okay, so tomorrow I'll start with both. I'll start with 2D arrays and I'll cover the sum and subtraction. So that will require 1 hour, and 2D arrays is fine. 2 hours of for 2D array introduction is fine. Okay, we have a Saturday's class morning 11 to 2. So Saturday, Sunday you have classes from 11 to 2. That's confirmed. Okay, and this Saturday you also have a module test. So that is going to be on nested loops, arrays. Mostly 2D arrays won't be there. So nested loop arrays still there, it will be there. Okay. Can we reverse a string without using string dot length? Oh. Without using string dot length. Using string builder, there is a function in string builder to reverse that you can use. But apart from inbuilt functions and without using length, I don't think it is there. It's module passing test. No, it's just for your practice. See, you would have 3 contests before your final module test. You have to appear all of them. I'll say, please appear all of them because that will give you idea about how your module test is going to look like. The students don't appear for these tests and they directly sit on module test and they say, ki, sir, that was very difficult, right? I was not prepared for that. So don't do that. Appear for this. There is nothing that is going to get evaluated based on this. It's just that you have to appear at least one to be eligible for module test. Okay, you should appear at least one of the weekly contest to be eligible for the module test in the module, right? That's the only criteria. Apart from that, like there is nothing, but you should appear all of them. If you're not getting evaluated, if you're not getting just, you just have to appear. So that will give you some idea about, right? No, it's just appearing for now. For this like weekly contest is just for appearing. That's there for your practice, right? There is no evaluation that is going to happen based on this. No module shift, nothing. Module test is completely at the end of the module. Before that, we'll have a lot of revision sessions. You'll have a lot of a weekly contest that you can practice for that. Okay.
सर
Yes.
सर जो जिम क्वेश्चन है ना उसमें कुछ क्वेश्चन टैग में मतलब हार्ड क्वेश्चन में कुछ 2 पॉइंटर्स और ऐसे कुछ और भी टैग है
So
सॉर्टिंग
जो टैग्स है उसको मत अटेम्प्ट करो. सो फॉर एग्जांपल लाइक सेड डीपी सॉर्टिंग 2 पॉइंटर्स ये सारे कॉन्सेप्ट जो एडेड है ना जो हमने कवर नहीं करे उनको अभी रहने दो. ठीक है. सो वहाँ पे टैग्स सो दिस इज फॉर एवरीवन. सो मोस्ट ऑफ द टाइम्स arrays questions will also have additional tags like dynamic programming or 2 pointers or stacks or queues. So firstly look at the tags. ठीक है. And then try to like attempt the questions. Also there is one filter for the module wise. So you can use the module filter and then select the like arrays or something. So module 1 does not have 2 pointers, TP or stack queues. So it will only give you those array questions which are not having these tags. Okay. So that was one filter that was added to the portal.
सिर्फ एरे वाले क्वेश्चन ही सॉर्ट करना है ना सर.
हाँ सिर्फ
सिर्फ
array
array.
वाली arrays, yes, सिर्फ only arrays. And you can use like sub arrays wala part is also there. So sub array is this itself, right? Whatever we understood today, that is sub array. Achha, how many chances we get for clearing module test and interview? So module test, I guess there is one. I guess you get 2, but confirm with your batch manager. Earlier there was 2, but now is it 1 or 2 that you can once confirm with your batch manager. Okay, but I like just follow along the course. We are so whatever we are learning is very advanced, and whatever you're going to get in module test, trust me. Okay. So what if like 10 people ask for referral? How will you deal with it? Is it necessary to have open role before applying referrals? No, actually interns are mostly hired on campus. There is off campus like drives that Microsoft or other companies also do. So off campus drives, off campus openings are there in the portal. So any off campus hiring is always happens to the like career site. So that is always going to be there in the career site that is listed. In like on campus hires might like there might be a different process altogether for that, right? Now for like referrals there need to be a job ID, otherwise like the referral is almost equivalent to nothing, because no recruiter is going to go through a referral which is not attached to a job ID, right? So that's why job ID is important. Okay, understood. Module test, everything. So please complete this. Try to practice more array questions. See, array is such a topic. I'll tell you, if you are spending time on it, that is going to help you in all the other topics going forward. Be it array list, linked list, tag queue, all those questions are going to look easy. Okay. So try to do that. Is module test hard? No, module test is, I'll say honestly, it's not very hard. Ready? If you just solve assignments and gym questions, right? If you solve decent amount of questions in the module, it's very easy. If you don't solve questions, it's going to be hard, right? So solve questions, that should be your test. That should be your goal. Okay. If some random friend email in there becomes with good profile. So I generally check the resume, right? It doesn't matter if I know the person personally or not. If the resume looks good, so I refer it, right? If the resume is not very good, so generally I provide some feedback. That's what I do, right? So that can help build it, because otherwise if I just refer it, it's anyways going to get rejected, right? So yeah. Master DSA for front end wise, I'll say ki DSA is you need to know. So this is like whatever we are learning till module 2, you need to know everything, because without that is like basics that you need to know for front end, back end, anything. You like not too very advanced. For example, array, there can be very hard questions as well. So even if you're solving medium level, medium to hard, that's fine. Okay. But yeah, try to solve now. Don't focus about front end, back end, whatever you're going to choose forward. Try to solve as many, right? If you have doubts, I'm there, right? Use the doubt session. That's what we are here for, right? We'll try to make you the master, right? We'll try to make you the best, right? If you try to be the best, you'll reach somewhere near that, right? So that's also fine. Passed out in students internship, I guess generally not, but it varies. It's not completely right. Passed out students don't get internships, so it varies. But generally, like they prefer college hires, but you can get a full-time role. That's always there, right? Full-time role would always be there. So by passing from ACU, you would directly go to a full-time role, because you will have more skills than any software engineer at level 1 engineers levels, right? So you'll have, I can assure you that you'll have more than that skills. Module test. So whatever questions you're solving in assignments, variations of that, little bit hard, easy, medium questions you'll get based on that. So it will not exactly be the assignment questions. It will not be exactly the Zim questions. It will be variations of the kind of questions that we have discussed, that you are solving in assignments, that you are solving in the Zim sections. So similar kind of those questions. Okay. Sure, Rakesh, that that's our goal is, right? That is our goal, to get you all placed into top product-based companies. That's what our goal is, right? So we try to prepare everyone to that level, right? So even not if you don't get directly after a Q job, you have that skills to get after 1 month, 2 months, 5 months, 7 months, and students have done it, right? So even if they don't have after directly from a Q job, few students have even been selected to Amazon Max out. Few students after 6, 7 months, they keep on applying and they get one opportunity. Since they are fully prepared, they are easily able to clear the interviews. Right? Lead code has the same question that's there in the portal, right? In portal, it is way more organized. We are like having, I'm there to cover it in the portal's order. So you can just follow the portal that is having the same amount of difficulty that lead code has. And we have just curated questions. In lead code, you might get a little bit lost for now. If you'll see a lot of questions, and you won't even like, you might face difficulty to figure out which one to solve now, which one to solve later, right? So in portal, you have that clarity, right? Which one to solve now, which one you can park for later, how you can filter out questions, and how where you can get these doubts addressed. So everything is there, right? So thank you, everyone. Like today's session, I really like the session because we had a good discussion. So tomorrow we'll try to complete this. We'll start with 2D arrays. We'll also solve few more questions on this. Try to solve sub-arrays questions. Try to practice a few sub-arrays questions on the Gym as well, since there are very few of them in assignments. So try to do more of them from Gym. Okay. Thank you, everyone. See you all tomorrow. Good night. Bye-bye. Take care.